Okay, perfect. We are on. So we can go ahead and get started. Let me welcome everybody to day 2 of my Institute on Computation and Statistics for Mass Spectrometry and Proteomics. So yesterday we had Lindsay Pina and Sio Abatiello talking about the basics of mass spectrometry and the basics of Skyline. And so today I am so very delighted to welcome Brendan McLean, who will spend the whole day today and in fact tomorrow talking more in depth about Skyline capabilities, and also how to work with Skyline for analysis of various types of data. So I'm really, really happy to have this opportunity today and tomorrow. Before we start, if you're joining us today for the first time, let me just walk you through some logistics. So we have the chat at the bottom of the screen. So let us only use chat for things such as, hello, how are you? And maybe I can hear you or something like that. But if you have questions related to the science and the scientific content, let us use the Q&A, which is also at the bottom of your screen. And the reason for that is that it is much easier for us to keep track of Q&A and manage them and move them out of the way when they're answered than when it is in the chat. So let us try to move all the science-related questions to the Q&A if possible. So let me just make sure we do a proper introduction to Brendan. So Brendan had worked at Microsoft for quite some time, where he has been doing a lot of interesting work, in particular managing Visual C++ and Developer Studio project. But then in in 2008, so like closing to 15 years now, Brendan joined the University of Washington and Mike McCaw's lab, where he was at the beginning of the Skyline project and now is the lead developer and the lead of the entire Skyline project. And I think saying that the Skyline project impacted proteomics community in numerous ways is an understatement. So the impact of this work is really tremendous. Among many awards, so Brendan was the inaugural recipient of the Gilbert Omen Computational Proteomics Award of the US Human Proteome Organization in recognition of Brendan's many contributions. And Brendan has been with my institute from the very beginning. So I am really honored to have Brendan as a collaborator on this and many other educational efforts for many, many years. So thank you, Brendan, for joining us this time. And so also I would like to introduce our teaching assistants, who are also going to be active participants in the program. And so when Brendan will be presenting, our teaching assistants will be also the ones answering questions. So let me introduce Ali Marsh, who has been a active contributor to some aspects of Skyline, in particular Skyline Batch. So Ali is in her last week of undergraduate studies at MIT. And so we are looking forward to see what's coming next. And also Juan Camilo Rojas Echeverri, if I'm pronouncing Juan's name correctly. So Juan was also with us last year as a teaching assistant. So Juan just became a postdoc in the Martin Luther University of Halle in Germany. And also Diane Plobel, who is now a PhD student in the Mike McCaw's lab at University of Washington in Seattle. So thank you very much in advance, the teaching assistants. I know that without you, things are much, much, much more difficult. So thank you for being here. Okay.
All right. Thank you, Olga. Yeah, we started teaching together in 2013, I think. And before that, we collaborated on stuff. So it's been really great working with Olga all these years, and especially around instruction. Instruction's become a big part of Skyline, which we'll talk about in a moment. But first, I wanted to try to get some interaction. Until the pandemic, a lot of our teaching was live, and we were still kind of trying to figure out how to teach and engage people online, although I think we've gotten better at it over the last couple of years. But I wanted to first just ask some questions of you, and I'm going to do it through this. Where does it? It doesn't have start to display poll shots on the slide. So I'm used to it showing so people don't know what this poll is, right? I'm used to it showing me a QR code that you
just
can
have
get
some
to.
3 lines. Yeah.
What? It just has that there's no QR code. So already we have a slight hiccup. Yeah, let me see. So if you see me looking off to the side here, I have 2 screens and lots of, so do I have to do, what would I have to do to, it doesn't have the QR, start presenting this way. Poll results on this slide. I'm presenting, right? Maybe if I get out of presenter view. Wow, that will be really unfortunate if I can't. Well, maybe because I'm presenting here. So if I just do one,
you can stop sharing your screen for a second if you.
I'm gonna try. Okay, so now we're okay. So that it was because I was having 2. Well, I'm not sure that's the right slide. Okay, so here we go. So this is the QR code, or you can join Slido and use this number. So yeah, if you have a phone, you can just hold it up to this QR code, and yeah, so we've started to, this is also a nice way to tell how many people are actually active. We've got 91 people, 91 participants in this meeting, and we can get some sense of, I mean, these are easy questions, so everybody should answer them. So if you don't answer them, I'm going to assume that you've started this session and walked away for some reason, maybe to get your coffee or whatever. But it gives us some sense of how many people are actually in the room, just like, when we're doing these live. So a lot of people have never used Skyline, so that's pretty typical. Although certainly even the fact that we have 50% that have done something with Skyline is much different from when we started doing these things. And it would be more like, most, maybe 25%, a quarter, would have any knowledge of Skyline at all, even know that it existed. Okay, so we've got about maybe 65 people active. Let's go to the next one, and that's pretty typical. So what is your expertise with DIA? Have people done DIA experiments? It's, it's still a relatively new technique, or at least over the last decade, compared to 30 years around for DDA and peptide searches, which people still use quite a lot. Okay, so yeah, there we go. Yeah, I like that. Tried but confused. Yeah, I tried to do this, but it's still a challenging technique for me. So and nobody expert. Okay, so that's okay. And we've got about our 60, a few more people showing up now. Let's go on to the next one. If you're using, so this is just free form. If you're using another tool for DIA, what is it? So some of you might have started trying. I mean, as Lindsay, I think, showed, there's a number of, DIANN is becoming pretty popular. And MaxQuant, has something for it as well. And then of course, Spectronaut is usually something. Wow. So why 2 DIANNs? Because it's capitalized different. So, okay, yeah, so that's, oh, I don't even know what this is, but that's not a tool. So Spectronaut and DIA-NN. So yeah, that's, I would say from, well, we haven't got, okay, so 36 people, probably not everybody has actually used the tool. I would say that DIA-NN is increasing in popularity based on this question from last year as well. But let's move on. Okay, so what is your expertise with quantitative DDA? So if you've if you've ever done used some sort of tool to do quantitative DDA, like that's another way to get quantitative metrics out of what I call I call it survey acquisition, where you're just looking for at just the entire proteome and trying to get some sense of what might be going on or what might be changing. And people use a lot of different methods, some of which, for a number of which were covered by Sue Abitiello yesterday. And so people are, out of our 70 or so people here, a lot, I guess, certainly more than DIA. People are using, 40% are using it regularly. 30% have never tried it. So yeah, that's tried but confused and expert. Okay, so we've got about 40% that are using it regular, or 50% that are using it regular or expert, which is kind of what we would expect. Lots of people use DDA for their quantification. And then finally, if you're not using Skyline for quantitative DDA, probably very few people are, but it's totally possible, and it's still a great tool, and it's a great tool for looking at your quantitative DDA results. Again, Skyline is one of the best tools for looking at your data. So yeah, Max Quant, that's pretty expected. Proteome Discoverer is also, fairly common, because a lot of people are using thermo instruments. Somebody keeps giving us emojis, and somebody keeps giving us numbers. I don't know what. So, wow, straight in Excel, mascot and peaks, or that we would expect some of those. And FragPipe, yeah, I think FragPipe is also becoming a bigger, getting more popular. Okay, yep, this is Max Quant and Proteome Discoverer would be the ones that I would expect at the top. And you can see that they show up with like progenesis and various different, I don't know why this Proteome Discoverer doesn't get folded into the other ones, but anyway, so there we go. That's a good, I think you're sort of statistically similar to most groups we've seen. And those are the tools that get used. And then, so what are you, and this is free form, what are you hoping to get out of the next two sessions? You probably read a little bit about them, and thinking it's always good to know what people expect coming in, and we can make sure that learning and knowledge, yeah, that's great, but about what? A better understanding of DINS. Okay, so yeah, peptide annotation with Skyline, getting started, DIA data analysis, use Skyline, DI expertise, streamline data, better Skyline. Well, obviously, with all things Skyline, you've come to the right place. But yeah, we're going to focus on large-scale DIA analysis with Skyline, and specifically, just really learning to do it at a large scale and make it reproducible, and so when you publish, somebody else could redo your experiment pretty easily. Okay, so that's, I guess we're going to move on from that. Those look good. Okay, so this is actually, so there, if we look at what tutorial, so if you didn't fully read the instructions, it's pretty far at the bottom at this point. It says, hey, to get the most out of this session, you should do a tutorial. And I'll point to that tutorial again. And some people last time did the tutorial between the two sessions. yeah, obvious. It's if you do the tutorial, if you really want to learn about DIA, then doing that tutorial is you'll learn quite a lot, and there's quite a few tutorials. So we're up to 60 people already. So very few people did it. 10% did it. Wow, that's impressive. And hopefully I'm going to stick around after these presentations, and I'm happy to just have office hours for those tutorials or talk about whatever else comes up. But so let's keep going. And then so we actually use the responses to this question in the publication for Skyline Batch. And the question is, what is your expertise with scripting? So do you write batch scripts? Do you write R scripts? Are you able to, just write scripts? They're kind of little programs, not the sort of the large kind of program like Skyline is, but just writing some text that controls your computer. So yeah, and that what we found last year, and part of why we created Skyline Batch was like there's a large part of the population that uses Skyline that doesn't use scripts at all. And so we have to, and usually the people coming to Olga's courses are biased toward being able to use scripts and write them. And they, hopefully some of you will stick around and learn how to use R better in RStudio. If you're in RStudio using R, you're writing scripts. So but even here, we see almost 50% of people who don't use scripts at all, or they use them occasionally. Maybe they don't write them themselves, they're just using somebody else's script. But so up until last year, I would typically present a script and say like, oh, this is a great way to run Skyline. I wrote this script. All you need to do is edit it. And then I realized that, oh, a lot of the people that I was working with were not even ready to edit a script. So did you get R installed and configured? So this is, that was part of the instructions, was to get R installed. Ideally, I found that I had the best success if I just went straight with R 4.0.3, which we give you a link to. And I actually ran into problems if I use the latest R, which is 4.2. And so kind of go over that. Hopefully we can get everybody up to speed. This is awesome that people got it installed. Hopefully, and so not as many people managed to get MS Stats installed. So we'll try that today. I think that I can give you what you need to get MS Stats installed today if you have R 4.0.3 installed. So if you don't have 4.0.3 installed, go ahead and install it now. You can have multiple versions of R installed, and I'm going to show you how to set RStudio to look at 4.0.3, and that's what we're going to use for MS Stats in the rest of this session. So, okay, so there we go. Thanks. There's about 60 to 70 people responding pretty quickly. That's super nice, and that's the end of the questions. Very helpful. And now I'm going to you have some time on your computer because I'm going to go into would you like to get to sure. So I'm going to go into that other presentation that I turned off, and I'm going to be presenting, and hopefully you can pay some attention or a lot of attention to this presentation, but also if you want to get R installed or start something, you have a moment before we get into, we'll have a break before we really get into hands-on stuff ourselves, I think. But yeah, so first some slides, and then we're going to get into hands-on work and hopefully give you a chance to really learn the material. So this is the Skyline project overview. This graph in the back is startups over time. It's always a trailing 7-day average. Because there's quite a lot of, use drops a lot on the weekends, but you can see all these different versions. Starting out here, the light colors are 32-bit, so Skyline started out 32-bit, and then right around here we introduced 64-bit, and then we finally have dropped 32-bit, you could see that it was just disappearing in use. So everybody's using 64-bit computers, and you certainly would need to do that for large-scale DIA. So we have much bigger computers than we have. Yep.
You're not sharing your screen.
I'm not sharing my screen. Did I stop sharing my screen? Huh. Okay. That would be a problem. Thanks for telling me. Zoom. Okay. Where? Wow, I can't even find the Zoom controls at this point. I'm gonna have to stop my, oh, because you're not watching it anyway. Okay, so Zoom. Wow.
And if you don't mind, there's a couple of version related questions in Q&A.
I've lost this. I have just the Q&A. Wow, I might have to go out of Zoom and come back because I've lost the controls. That's very strange.
Maybe try exiting full screen mode and might make it visible.
Exiting full screen. I just don't know how to exit full. I'm not even sure. Did I minimize it or something? Wow, never. Wow, I can leave. What I think I have to leave the webinar and come back. I'll be right back. All right, sorry about that. Okay, so I'll share my screen. Okay, too many screens, too many things going on here. Okay, so let's go back to that. So yeah, I guess I was trying to show this. And so yeah, so Skyline project overview. This is a graph of over time the versions of Skyline. And so you can see that there's been quite a lot of growth in the use of Skyline. There's 2 years here that are cut off. We're in the 14th year of development, 14 ending in August. And then we'll move on to our 15th year, which I'm really excited about. And I'm just excited about the accomplishment of offering free software for 14 years. 8 developers now, and then we have a project manager and 1 person focused on IT, keeping the Panorama server and all of our servers healthy, and doing a lot of the background IT work that is now necessary to keep Skyline and its infrastructure alive. Skyline itself has over 750,000 lines of C# code, not including the Proteo Wizard code that we use as well. It's all open source. And you could go read the code if you want. There's 100,000 lines of those code that are dedicated to testing. We do a lot of automated testing, and that's how we try very hard to ensure that we never break things, and you can always rely on the results you're getting out of Skyline. There are over 20,000 registered users now. Or at least there are 20,000 email addresses that when we make a release and make a release announcement, 20,000 email addresses get that release announcement. 4,300 are registered for Skyline Daily, which is the beta release. And last year, we actually had to use Skyline Daily in this session because what we were doing was so cutting edge. And thankfully, this year, we've gotten all the features that you need into the standard release. So you can just be one of these 20,000 users. But if you want to check out the beta, you want to play with some of the newest features, then Skyline Daily is the place to go. There's pretty stably over 10,000 instances started in any 7-day period. You can see that over here. This is the 10,000 line right there, around there. And since we first started letting people download, there's been over 145,000 downloads, and obviously a single person could download many times. I know I have. And then the original paper has over 3,500 citations, and now we're even encouraging people to cite a paper from Lindsay, which is a little bit more extensive, has a little bit more information about the whole Skyline ecosystem. And then it is now very stably funded by, we've got 4 years and a 5-year grant that's quite, that, you know, that is acknowledges Skyline, that Skyline's become a community resource. So that's pretty nice funding. And then the instrument vendors, we have 6 instrument vendors, and half of them now pay us through 3-year contracts. And so, yeah, there's no fear that Skyline's going away anytime soon. So Skyline itself, I came up with this term chromatography-based quantification to differentiate it from what I considered spectrum-based quantification for TMT and mass tagging, where the quantitative metric is inside a single spectrum. Skyline, as Lindsay showed yesterday, does this, you know, either extracts chromatograms or has chromatograms and uses the area under these curves as a proxy for quantity. So that's what it does. It supports 4 different acquisition methods. I think you were introduced to most of this yesterday: SRAM, PRM, DIA swath, which is what we're going to focus on today, and also DDA. So it, just like MaxQuant, it can extract chromatograms from MS1 only and give you peak areas for that and do quantification off that. And I then break these methods down into this 2x2 grid where there's an acquisition mode, whether it's targeted, meaning you have to decide ahead of time what you're monitoring and tell the instrument what to monitor. And Skyline is probably, I think, hands down the best tool if this is where you are. If you're doing PRM or SRAM, most people acknowledge that Skyline is the tool to choose. Out here, DIA, DDA, obviously there's lots of other choices. You know, we saw some in the poll results, and MaxQuant's probably the favorite here, and then DIANN and Spectronaut are out here for this survey, but we're going to use Skyline, and Skyline does perform, you know, quite well, and that's been shown several times in software comparisons. But this is where you set the mass spectrometer up with some general parameters and you run it, and then you go analyze the data afterwards. So you don't have to make any choices, or don't have to make that many choices up front. From its inception, Skyline has supported 4 of these 6 instrument vendors. The other 2 came along afterwards and said, wow, we would like to be part of this group. And so they're now all funding the work with Skyline, and we work very closely with the people at these companies, and they're very engaged in making sure Skyline works with their latest advances in their instruments. So that's a really great relationship that we're happy has flourished over so many years. We've been very focused on teaching since 2013, when Olga and Mina and I kind of said, hey, let's do a workshop at US HUPO. And then that was followed by a course at ETH with the Aebersold lab, which is now actually sadly no more. But you can see 2018, I think, was our apex year, turned out to be our apex year, where we did all of these courses all over the world. These 2 were new at the time and we thought, hey, you know, both groups said, we're going to keep doing these. And sadly, you know, I don't think either of them have lasted, and it's going to be interesting to see what comes back after we get through this pandemic. But 2019 was similarly still pretty exciting. A lot of teaching all over the world, again, in person, small groups. You can see 25, 28. We tended to really like these small groups where people could come and create relationships with us and with each other. This was, you know, some plots I made in response to Mike saying, like, oh man, there are these, you know, mass spec courses that are getting like 200 people. And I was like, yeah, but we're trying to keep ours under 50. And if you look at how many people we serve over 200 people a year too. So that was pre-pandemic. The pandemic forced us to start teaching remotely. For the first year, the only two courses that really survived were this May Institute, and we started the UW, which had been doing an in-person course in Seattle, switched to Skyline Online as well, and that was very popular. We would get 50. Then we contained our size to 50 people and sold those courses out in under 48 hours. Again, in 2021, both of these, and then the Barcelona course put on by the folks at PRBB, this EMBO practical course, that came back in 2021. 2022, we've done another Skyline online. You're at the May Institute for 2022. We're also kind of hoping that teaching in person is going to come back in 2022. Still a question mark here, but it's looking, we are making progress on being able to offer a course in Seattle. The announcement for that is coming soon. If you want a 5-day in-person week-long course, this is a great way to learn a lot, meet people. And yeah, I think that even though you can take these online things, I really think that getting away from work, getting away from your computer, those of you who are actually doing anything but paying attention may sympathize with this. It's really hard to keep your attention on the material, but it's way easier if you're in a room with everybody and you've got teachers around you that are trying to help you stay focused and on track and learning. So these are a few things that we hope are coming back this year, and hope to see that grow back in future years as well. So yeah, so much to teach, so much to learn. I love this quote. This was in Barcelona after the 5-day practical course, which is a great option if you're in Europe. And hopefully the Barcelona course is coming back in person this year. But this person said, I realize I'm only using 20% of what Skyline can do over dinner after the course. And my response was, we only taught you a fraction of what's possible. So, maybe you're only using 5% of what Skyline can do. And Skyline has grown, this is probably 6 years ago. Skyline has grown quite a lot. So there's even more stuff that you might not do, but just like Excel, which has been going for, I don't know, 30 years, 40 years, you can learn a small amount, become effective, and expand from there. And maybe you never do. I certainly don't feel like I use all of the functionality of Excel, but it's extremely useful to me. So there are now 23 written tutorials, and yeah, there's a couple more getting added. We're adding them all the time. We went through a major push during the pandemic to update them to recent software, because some of them were getting a little long in the tooth. So these really still, if you go and use them now, they represent our best effort to update and write about the most current best practices in Skyline. And we also do these webinars. Had a big push in 2015 where we put out like 10 webinars in a year, and we've slowed down a little bit since then, but we just did this cycle of 3 where we did the DIA swath webinar to go with this tutorial, which is the one that I asked you to do. And hopefully people will be able to get back and do that. You can also watch this webinar, which walks through some of the parts of that. And then we introduced IO mobility spectrum filtering with Aaron Baker, who is a leading expert in that area. And then finally, on to the timsTOF and DIA PASF. And so this was a nice little trio that I envisioned. We did eventually get there, but you can see that there's a gap between 19 and 21, which we needed Ben Collins to collect DIA PASF data and sort of get through creating a tutorial that is the companion tutorial to the ones that were created here back in 2018 was when they were created. So the webinar that got in the middle of those three while we waited for Ben to get us the right data set was this one on Skyline Batch, highlighting the work of that Ali Marsh did. Really a great, nice body of work over a year. She took a year off from MIT. You just heard that she's finishing up at MIT. She decided during the pandemic not to do her final year remotely. And that was great luck for us because she came and worked on the Skyline Batch, which became a paper published in JPR 2021. Here's the title and reference for it. And then here are links to the Skyline Batch installation page, which hopefully you've already gone to, as well as Skyline Batch documentation. And then this is an overview figure from the paper. But yeah, so we're going to learn how to use Skyline Batch here. It's a great tool, especially if you want the full power of running Skyline in batch mode without writing scripts. That was the goal. And then we're also going to be looking at Panorama, which was another part of the growing Skyline ecosystem, and introduced in, I think, around 2013. It's coming close to being 10 years old as well. So you can anybody can create a private project. This is the way Panorama, the way we envision Panorama, just as a server-side repository extension of your use of Skyline. But eventually we realized that it would also be useful to have an official public place to then publish your Skyline processing. And so we created Panorama Public, which is now part of the Proteome Exchange. And you can get a Proteome Exchange ID that you can publish with your manuscripts. There's currently 370 public data sets with 80 in review. There's probably at this point, there's generally about 80 in review at any given time. And we're seeing over 100 data sets published each year. And that's growing over time. But Skyline Panorama also allows you to do longitudinal instrument QC. Biopharmaceuticals MAM is a way of monitoring QC of biopharmaceutical production. So we're working with several biopharma companies on that. Quantitative support, and then we have this ability to build chromatogram libraries that are equivalent to spectral libraries. So if you're working in Skyline and you want to actually preserve all the chromatogram data, you can create a targeted chromatogram library, and you can get way more extensive than you can get with a spectral library on assay validation, and this is a very rich place to build library information about your mass spec data. Anybody can get a project here. You can get a project for yourself, for your lab, and for a multi-lab organization. We see all sizes of projects. There's over 550 separate projects right now, and they're all, you control the security, whether you want it to be just you or all your friends or whoever. You can decide who gets to see your project. There's 10,000 data sets of the type that, these Skyline documents uploaded. And then there's 15,000 QC docs. So that means people who are monitoring their instruments with Panorama Auto QC. And then it's also possible to have a locally installable server, get your own version of Panorama. This one's maintained by us, but some of these organizations wanted their own, because they need to have the server behind their firewall. So, okay, so on to what we're going to be studying. So that's kind of an overview of the ecosystem that we're going to explore, the Skyline ecosystem, which extends beyond just Skyline itself now. We're going to be exploring this experiment, this two-phase experiment. We're actually going to use the data from this 2015 paper, Bruder paper, which I thought was a pretty, I thought that was a really informative paper, and so it's still how a lot of people approach DIA. So it's worth is still looking at. There are obviously new ways of approaching DIA being created that don't require this building a library, but this is still a useful way to look at things. So you have your quantitative samples, pool them into a single pool of the sample. So that accounts for, well, there may be changes in these samples, and so proteins may be visible that, you know, in some samples that aren't in other samples. You pool them, and you just run DDA, and you can run you know, a bunch of runs of DDA. And at this point, we're not doing any fractionation. We just, like, on this sample, we run a bunch of runs of DDA and see what we can detect. And we build a library out of that, and then we go back and interrogate the DIA with that library. So that's, so and it's not required. There's not any special ordering here. You could have acquired the DDA and then acquire, or you could have acquired the DIA on all of these and then go acquire the DDA and then go back and interrogate your DIA files. But but we start with a first experiment that says, well, if it's detectable with DDA, we should be able to detect it over here with DIA, and we should be able to detect it lots more consistently. So this is a, you know, this is a figure from that Bruder paper showing that the number of runs in which something is detectable, and so HRM is DIA, is a synonym for DIA, and you can see that we can detect things in, you know, very, very consistently in all 24 runs. Most of things are detectable, whereas if we just let DDA go, it's unlikely to, you know, it detects these things in all runs with far fewer cases. So in this impacts, if you're using TMT as well, you have to realize that you're just not getting measurements in every run. And this was then a plot of that, you know, here's it's a 2D plot of that same thing. All the white spots are missing data, and it's just showing that there's lots less missing data with DIA. But the one caveat is that if you read the paper closely, it says no feature alignment was used, and that's, you know, that's not really how people do things with MaxQuant. Most people would use feature alignment, and so while this plot definitely, this is very accurate for TMT, where you can only get the quantitative measurements out of the MSMS. People doing using MaxQuant will do something like this, and this is a plot from Skyline. So you can see here's 9 runs, and here's these chromatograms here are the precursor chromatograms extracted out of MS1. So this is Skyline doing MS1 quant. It would do alignment too. You can see that there are only some runs. These little ID annotations show you where the instrument sampled an MS spectrum, and then that was identified by a search engine. And so here, this is actually pretty unusual to get an ID right in the middle of the peak. Frequently, we get IDs on either side like this. And the cause of that is that this is so abundant that it gets seen really early, it gets sampled, and then there's dynamic exclusion, and then maybe it gets seen again after the dynamic exclusion wears out if there's enough still left. But you can see it's only detected in certain runs, but Skyline uses alignment. These light blue lines are sort of Skyline saying, hey, well, if this ID were to be mapped onto this other run, this is where it would show up. And then you can see that there's actually there are quite nice peaks. So it's not clear why the mass spectrometer didn't sample it, other than the fact that it is quite a bit less. So yeah, when these middle ones are where it's really high intensity, up around, you can see like 3 billion ions per second. And down here, we only have like tens of millions of ions per second. And frequently we're not sampling it because DDA, that's the way DDA works. And so the experiment that I just mentioned, Bruder would then treat this like, so those are the IDs. And so what they're saying is that in the experiment, they treated anything that didn't have a direct ID, so no cross-run alignment, as if it were missing. So I think that's a little bit overstating the problem. We can do better than that with MSMS, but still, the point remains that with DIA, we do get much better coverage and much more selective and better peak areas. So, and a really important concept that, you know, as we were doing SRM back in the day with Skyline, we realized, you know, a key concept that is allowing us to get more information out of our mass spectrometry data is prior knowledge and consistency. And there are just things that we measure with our mass spectrometer that are highly consistent across runs, and if we have prior knowledge of them, we can do a better job than just every time. Rudy Aebersold used to have this thing saying, like, we need to stop rediscovering our data every time, because frequently that's what we're doing, is we have a FASTA file and we treat it like all we know about this data is we know that it could have anything in this FASTA file in it. And we go out and we search the data every time without using any prior knowledge, when actually we know that relative product ion abundance is highly consistent. You saw that yesterday with Lindsay. We would see these, you know, stripes of many runs. You know, the transitions were very, very consistent across the runs, and we encode that in spectral libraries. So one of the key things about spectral libraries is they tell us what the relative product ion abundance is. And now we have predictors like PROSIT that can just predict these from a peptide sequence. And those are highly useful, and I recommend using them. And we talked about that yesterday. And then there's retention time, which is also highly consistent if you're using the same chromatography, and especially if you're on a single column run to run. So, and then we have learned to encode these in what we call IRT libraries, and these can all be wrapped up together. And then, so these are powerful enough to be used cross-lab and cross-experiment. So that allows us to measure, store, and reuse them, and then more powerful run-to-run. So then that's what we were looking at yesterday, where we could say, wow, we really expect the retention times to all line up run to run, and we really expect the relative ion abundance. So that's what this looks like. Again, in a slide that you saw this with Lindsay yesterday. This is actually the same data set you were looking at with Lindsay yesterday. But yeah, when things are working well, we see this and we go, oh, looks great. You know, the relative ion abundance is very consistent. Each one of these colors is the extracted peak area for a certain fragment ion in an SRM experiment. And the same thing applies for DIA and even DDA. For retention time, what we're saying is we've learned that when we use the same chromatography, and especially the same column on the same instrument, we get highly reproducible relative retention times. So these are the IRT peptides. This is from the original IRT paper, which I co-authored with the folks at Biognosis. That was a great paper to work on. I appreciate them including me and Skyline in it. But yeah, we see that these peptides come out in this pattern. And then in that paper, we showed that, yeah, if we change the chromatography, they still came out in this pattern. And if we change the gradient length with that, you know, still using C18 chromatography, they came out relative to each other highly consistently. So even when we were changing the chromatography, they were coming out highly consistently. And that meant that we could map all the other peptides and give them values that essentially said how far they were from all of these other peptides. And then we could reuse that to know when peptides are expected to elute. So we're going to be exploring this prior knowledge workflow, which I've talked about in some of the webinars, where you do DIA acquisition, and then you apply a spectral library. And originally Skyline had spectral library and IRT library, and you can still have them separated. And this tells us what they're supplying us is relative ion abundance and normalized retention time. Yes.
Sorry, it's just because it's a little bit relevant to this before we moved out. So Timothy is asking, yesterday we heard that the fragmentation energy is fixed in DIA, but often not in DDA. So will DDA spectral libraries need to have the information stored to make them useful for DIA?
No, they don't. And you know, the IRT is a little, or I mean, the collision energy is a little bit sloppy, you know, there, as long as you're getting things in the right range. And so what people tend to do with their DIA is they, or at least the McCoss lab is definitely doing this, is when we acquire a range of DIA, we use the optimal collision energy for charge 2 of the center of that window. And that ends up being pretty good. And yeah, like, amazingly, just a fairly sort of normalized collision energy in thermo. That's what PROSIT is trained on. I was able to use that to really impressively good effect on SciAx triple TOF data. And you can go back and look at this, the PROSIT presentation I mentioned yesterday, that I gave at ASMS, and we actually even got better quantitative results, you know, in some cases, using PROSIT predictions. Which so yeah, I think DDA data is clearly highly useful and highly reliable. There are some cases where you'll go like, oh, okay, that doesn't quite match up, and I think I know why. But if you are doing DDA acquisition, you want to make sure that the fragmentation is the same. And so you're going to have more cases where things don't match up if you used ion trap CID fragmentation in a thermo instrument versus HCD. So there are some things to watch out for. But yes, DIA, we use tons of DDA data, and even PROSIT prediction libraries are based on DDA data. So DDA data has been highly proven to work well with DIA data. So then, yeah, so we do that. We target these product ions. So in DIA, we're targeting product ions, where in DDA, we would target the precursor and extract, and then we do chromatogram extraction in the MS spectra. And then apply an M-profit model to pick the peaks that we're going to use for quantification, and then we can do quantitative analysis. And that's, oh, and then we also, there was a comparison back when, before DIANN was not part of the comparison back at this point, but there was you know, these other tools are also certainly capable and do very similarly. And they also, the sort of unifying thing at that point was an assay library, which includes both relative ion abundance and normalized IRT. And we're going to see one of those because the data set we're going to be working with uses an assay library that came out of Spectronaut. So and Skyline supports that as well. So this is something I created probably in the first year or so, maybe year 2 of Skyline, was this idea like, okay, what are we really striving to build here? We're striving to build a, you know, this is Skyline here doing this thing we call targeted method refinement. And we're striving, and this is still what, you know, what Skyline is based on, this idea of taking prior prior knowledge of so taking that prior knowledge of retention time prediction, spectral libraries, unrefined methods, and previous measurements, and putting that together into a Skyline document, maybe doing some targeted method refinement, and then coming out with a quantitative assay which we can repeat over and over again. And we still think that this refinement is highly useful, and hopefully we'll get into that a little bit tomorrow. So even with DIA, it is possible to do some refinement and even just stay with DIA, or certainly you can use refinement of DIA data to get to an SRM method where you're very specifically targeting your targets of interest, and you'll get higher precision measurements. And I know that Deanna, who is a TA here, has a really good presentation, has done a lot of this work of getting from DIA down to SRM or PRM. So the idea is that you build a method, run the method, evaluate the results, do some refinement, and then you go back and use a new method. And what can be done in all of this refinement area is you can be checking for abundance, measurability of your peptides. You can actually even do a first analysis of like, do these proteins or peptides have any chance of differentiating the cases that I care about, and then you could just eliminate the ones that don't. And then there's peptides, some of them undergo degradation. There are some weird digestion things that could be happening. You can do analyses that are targeted at it. Can I just even get repeatable measurements of these peptides? And then we've also done linearity to see how quantifiable things are, and certainly scheduling and parameter optimization. So you could be doing all of this stuff inside Skyline and moving from the type of method we're going to start with today toward a more quantitative, more targeted method. So I guess then the other, so that's sort of like the design of Skyline, and what makes it unique is that you can go that entire range from large scale DIA or DDA all the way down to a very targeted method that you're going to use for SRM or PRM. And then another big thing about Skyline, Lindsay pointed out yesterday that the only tools on the list for DIA that allowed you to just look at your data were Skyline and Spectronaut, and that's been something that Skyline has offered from the start, and we continue to focus a lot of our effort on is really understanding your data and really being able to see with your own eyes every aspect of your data that we can come up with. And based on this psychology paper I was reading, or a book by Daniel Kahneman, a Nobel Prize winning psychologist, who had this Wizziati thing, which is what I see is all there is. And so I changed that to what you see is what you believe. If you don't, if you see stuff at a very high level, you'll make up stories and you might be wrong. And so we encourage you to use Skyline to see as deeply as you can into your data before you publish. And we recently got an email from somebody who was like, oh, I'm so glad I put the data through Skyline. They were using another tool and they ran it through Skyline and realized that the conclusions they were making were not correct. So Skyline is organized around this principle of directed investigation. And so I like to actually draw a parallel to Google Maps. This is a satellite view in Google Maps. And as I'll show you, we have a satellite view of our own in proteomics. But when I'm working with people in person and when people can actually just chime in, which is maybe not that easy here, other than people could write in the chat. But when in the smaller smaller courses that we do, even on Zoom, we don't use this webinar view. We use just a Zoom meeting, and people can speak up. But so I'm just going to have to tell you, at this satellite view, I would normally go like, well, what do you see? What can you know at this point? And I would say that, you know, hopefully people can see that there's this white here, and so that's actually snow or ice. And so contrary to the way my eyes see this, these are the highest points. And then there's brownish stuff around there. And that's, I now can know from the fact that I can see some ice, the brownish stuff is probably not desert, it's probably rock. And so these are mountains, and I'm in a fairly mountainous region. Maybe you can sort of derive from these lines where we can see the dark green is probably evergreen pine trees, and then we see this lighter green, which we maybe think, okay, it's, you know, maybe that's either, you know, why would we have lighter green after the darker green? And then, you know, you can maybe guess that that's farmland of some kind. There's obviously there's seem to be some rivers running through here. And, you know, down here, you can see kind of some turquoise things that are probably lakes. So you can learn quite a lot at the satellite view. But what if you decide, oh, what I'm really interested in is right here, right? And then, you know, are you going to go through square by square? Or wouldn't you prefer to just be able to zoom into that one little spot? And so let's see what we can learn if we get a little closer. And oh, wow, we can learn actually quite a bit. This is one step closer. Yes, definitely. These are trees now where there's no snow or ice or rock in this view. We can see that actually what we didn't see from the satellite view is that this is basically in some sort of town. There is clearly farmland, so, you know, there's some sort of agriculture going on around here. This is a very square lakeish thing. It's probably a reservoir. We can learn a lot from this, and we can actually even see, you know, here this is probably cropland, and this is an area that hasn't been planted. And we can see, you know, a number of these dirt patches that haven't been planted, which is something we didn't see necessarily at the higher level. And then if we zoom in one more level, we can see that this is actually where I was teaching at the time. This is a monastery. You know, we can maybe, you know, we could maybe see people in the courtyards, but we can also see, you know, here is a river for sure. And we can see that this is a soccer field, which we might have classified as agricultural before we got into this level. So at each level, we can learn new stuff, and that is exactly the principle that Skyline is designed on. And we can learn things about a very specific question. And we're the ones who came up with the question, well, what's happening right here? We didn't, you know, we didn't go like, well, okay, to know what's happening right here, we have to go through all, you know, this entire map. We were able to quickly zoom in and get a lot of information about the thing that we're interested in. And that's what Skyline's designed on. This is a satellite view in proteomics. Lindsay presented this very nicely yesterday as well. We get these heat map plots where all of the work that Skyline and other tools have done to quantify, you know, come up with a peak area and come up with a quantitative value are summarized across a number of samples and a number of targets, you know, and the number of targets could be tens of thousands, and the samples could be hundreds. But this is the satellite view, and we have to ask ourselves what's underneath these values. And if all you do is rush right to the satellite view and then even run a tool like MS Stats and then go, oh, these are my answers, I think you're missing a lot. There's still a lot going on in mass spectrometry that needs to be double checked and triple checked and very thoroughly assessed. And Skyline will help you do that. So looking, you know, I think actually it's a couple levels down from the satellite view is the chromatogram, is looking at the chromatograms. And so, you know, this is a plot from Skyline explaining how it got the peak area for this particular thing, that this little arrowhead is pointing at a peak apex. And it got the, and I'm going to highlight this with, these are the integration boundaries that Skyline chose. And so I'm going over sources of error. This is, again, these are precursor. This is MS1 quantification. It's not DIA, which we're going to get into in a moment. But again, we have these IDs saying, hey, this was ID'd here, and this was ID'd here with MS. And Skyline has chosen this as the boundaries. And so in a more interactive format, I would ask you, well, what's the problem with that? And the problem is that we think that the integration boundaries are not quite right, because we have an ID out here, and this to the human eye, the chromatography is very spiky, but to the human eye, we would put the integration boundaries out here. And so at the satellite level, we have undercounted the peak area for this peptide. Here's another case. It's kind of blurry, unfortunately, but again, I've highlighted the peak boundaries. This is Skyline again showing DDA. There's an ID in the back here. You can't quite see that well, and you can see this big brown spike here, which is clearly an interference. So if we were to do this manually or ourselves, we would have wished that, or we would wish that Skyline had integrated it like that, at least. Those are probably the best integration boundaries for the peak that we see. And I'm going to tell you that there's still going to be interference on this brown thing. It's not completely gone. So we're still getting signal from something else, but we're getting a lot less of it than we were before. And to actually get the most accurate quantification, we might want to eliminate this brown thing from our quantitative considerations, because there's obviously some other peptide that contributes signal to that brown thing. Here's another case. This was actually a bug report that somebody sent me, and they said, wow, why is Skyline picking this 27.2 thing when the 28.2 thing has an ID in the middle of it? It has aligned IDs. It must be that's the right one. And I ended up agreeing and fixing Skyline, which is another aspect of making everything incredibly visible, is your users tell you when there's problems and you get to fix bugs. And so we did fix a bug, but all these tools make these mistakes, and the more visual the tool, I think the more likely you are to be told that your software has a bug. So that was it. Incorrectly picked peaks. Okay, so now pulling up at the satellite level, what if we'd gone to that satellite level and we went, wow, or we'd even run MS stats and it was telling us, hey, this peptide, maybe it was telling us it was statistically different, but I actually start with, do people think that these are statistically different? That 1 is statistically different from 2 and 2 is statistically different from 3? And probably most people would say, yeah, we can't really say 1 is statistically different from 3. But what do people think about, are these statistically different? And unfortunately, you can't answer, but most people will go, yeah, of course, look at how different they are. I totally believe they're statistically different. And if you just do p-values on this single measurement, then wow, yes, way below 0.05. So that's a p-value is for a single measurement of 0.05 is something that we could publish, right? But this is an experiment where we probed 26,500 peptides. So we have to use adjusted p-values. And when you do use adjusted p-values, whoa, they are statistically significant, but just barely, right? Like we can still say the adjusted p-value is less than 0.05, but isn't that stunning? So, this looks to the human eye so incredibly different, but you have to watch out that you went and searched a ton of things. And so things like this are just going to happen randomly. Okay, so then we zoom in a little bit. Okay, we still think it's statistically different. You know, here's the actual variance that led to these whiskers. These whiskers are showing you one standard deviation, and the mean is the value. And then we pull those apart. That's easy to do in Skyline. And now you can see that we measured in triplicate 3 different samples, and everything still looks fine, right? And now I'd show this, and I would normally ask, like, well, so do you see any indication? We're zooming in through the levels just with directed investigation, really easy to do with Skyline. These are just Skyline plots that I'm put in slides. And already we'd be like, whoa, why is the I dot P, why is the relative ion abundance so different? We see a lot of the M+2. So the blue is the monoisotopic, which is supposed to be the most abundant, but here we see very much the most abundant is this M+2, and we see very little of the M+1. So now, so this has caught our interest, and we want to zoom in even further. And so here are the chromatogram plots, again, just displayed as Skyline would display them, very easy to look at. And we can already, we can get a lot of information just here. And this is probably as low as we're going to go in this case. We can see that we have IDs in the middle of this for 5 runs. 3 of the sample 1 and 2 of the sample 3, we have IDs. Here's one that's not ID'd, but it looks very similar to the others, and we can see from the alignment that these bluish lines, we're picking basically the same peak, not a problem there. But when we look over here, we don't see any IDs, and we see just very different, very different peaks. There's some big brown, something that is apparently heavier than our thing, because the blue is the monoisotopic. This is the purple is the M+1, and the brown is the M+2. And so we see that this is, this is probably caused by some heavier thing or something like that. So, and it's very hard to imagine, maybe you could say, oh, this thing over on the side here, you can see all the IDs are kind of lining up over here. So maybe there would be a way to get some signal out of the monoisotopic that you could use, but boy, it's hard to say that for sure at this point. So this may just be a case where you could not actually, with DDA, you couldn't actually get a valid quantitative value. And I think other tools like MaxQuant would struggle with this case too. Okay, so here's this is a second peptide. People think I would usually ask, do you think it's statistically significant? And it looks even more extreme than last time. And so when we look, yeah, actually the adjusted p-values are now even better than 1% false discovery rate. So less than 1% false discovery rate. These are quantitatively different, even though we looked at 26,500 of these. Okay, we zoom in one level, and hey, that looks fine too. Like now our I dot p values are really nicely behaved, look very much like the expected thing over on the left here. And we have I dot p values that are all, 0.96 and above. So not really anything to worry about at that level. But if we zoom in even a little bit closer, now we can see, okay, so wow, we have IDs in every run, so maybe we're okay. But wait a second, the IDs for these runs are kind of off to the right. And in these other runs, we actually see that there's, this dangerously close interfering peak next to our peak of interest. So we see that there's these 2 peaks. And we actually can even notice that we have like a 3 ppm mass error. So you can see it says the ppm mass errors on top of the peaks. We have a basically 3 to 4 ppm mass error, 5 over here on all of these runs, the sample 1s and sample 3s. And then in the sample 2, we see that we have a 20 ppm mass error. And actually, if we look here, the peak to the left has a 20 ppm mass error. So we're maybe starting to see, even at this, magnification, wait a second, there's some evidence that we actually are picking the thing to the left here. And then, if with Skyline, it's fairly easy to just put the cursor to the left and zoom in, and then we can see, oh, wait, that other thing is there. It's just, it's getting swamped by this. So the thing that's changing here is probably not the peak to the right, which is the thing we're interested in, this peak to the left. And we might really go, wow, what's that? I hope I can figure out what this is, because that is changing very significantly, but not the thing that we were hoping to measure. That's not changing significantly. But I would tell you that, like, there's no tool, Max Quant, no, Proteome Discover, there's no tool that's gonna be able to, that's gonna see this thing over here as anything but a shoulder on that big peak. So I think a lot of tools are going to make a mistake like this, and it's only through being able to zoom in and do directed investigation when you're like, yep, this is a great thing, I'm gonna publish, and then you use these tools, you can learn more and maybe save yourself some mistakes. So, and then the final level that we implemented in Skyline a while ago now was just the ability to point and click when you're extracting chromatograms from spectra, to be able to point at the chromatogram and see the spectrum that created the point. So here we clicked here and we can see this is profile mode data. And we would often recommend that you use centroided, but you can see these are the peaks and this is the isotope distribution, and there's 2 ppm mass error. This all looks really nice. But in terms of directed investigation, maybe you're like, well, what's this over here? Is that an interference? Because it's definitely bleeding it, it would bleed into this peak. Or is it, sometimes if a peptide contains a proline, you'll get this sort of double elution. Could it just be more of my same peptide? And that's now easily answerable with Skyline by clicking on the point and, in this peak over here, and you can see, oh, wait, no, this is a different peptide altogether that's a little bit lighter. So this is its monoisotopic mass. You can see that its mass error is larger, again, like the 2 peaks that we saw in the last thing. The mass error is bigger. So this is the way. One of the people in the McCoss lab, when we first implemented this, said, wow, it's like pulling the blinders off. Suddenly I can see all these things that I couldn't see before. So this is directed investigation that Skyline supports. This is the Skyline team. And everybody is, Emeritus Ali Marsh, I put her on here because we're presenting all her work this week, this session. So, but she's sadly no longer part of the Skyline team. But all of these people are working, very hard to improve Skyline and the Skyline ecosystem for you. And very responsive, we're here on the support board, very responsive to your feedback and questions, and want to help you use Skyline as effectively as possible. So, and that ends the presentation part of this. I'm going to take some questions, I think, and then we'll move on to doing some hands-on. We'll take a break and then we'll do some hands-on.
There was one question from Leigh Foster, but I think Diana is responding in now. I was kind of saving it because.
Well, I'll look at it quickly while it's here. I noticed yesterday that most of your peptides were less than 60 seconds RT reproducibility, which is awesome. Is this solely an effect of recalibrating data using the IRT, or was it a combination of factors? So this is saying that I guess the retention times didn't move around more than a minute. And that was not that yesterday's data was not our retention time aligned. So I think it was simply that our instrument operator did Daniela Tomazella did a really nice job of collecting those 42 runs with she collected them very over, I forget what, 2 to 4 days of acquisition. But yeah, the retention times did not vary greatly, but which is also important. But we used a 5-minute retention time window, and that turned out to be too small, even with the low variability in retention time. There was a lot of truncation where we lost information, which Lindsay showed yesterday as well. So I don't know whether Danielle or whether Deanna is still typing an answer to that one. Maybe not. I will say that it's answered live. Can participants, yes. So one thing that Olga suggested is we're going to copy and paste the full set of answers from the Q&A to the document. So actually I had this, so hopefully at this point, everybody has visited this document. This is the document for our session. And I've already, just last night, I added the presentation slides. So if you want the PDF, and hopefully some people like to have the slides before the presentation. So hopefully some people found this last night. But if you go to this document, which is linked to on the main page of the May Institute, right? So the way you can get to this document is just by clicking here. And then you end up at this document. Hopefully everybody has seen it. That's where it says preparation. In order to get the most out of this, work through the tutorial and possibly review this webinar 18. So those are ways that you could get more out of understanding DIA data processing that is not going to be explained here in this session. So that was the question about how many people got to the tutorial. You had to actually read to the bottom of this. There's other things that, we obviously asked you to install Skyline and Skyline Batch and RStudio and R. And it seemed like a fair number of people got through installing R 4.0.3. And then we asked you to visit this location and start downloading data. But yeah, so this is, and we'll, at the bottom here, we will post all the Q&A. So long answer to a short question. Okay. So Deanna is handling that one. For the replicate same precursors, how to sum them up for quantification. Thanks. Yeah, for the DDA data where we're doing precursor quantification based on precursor, and we've extracted the monoisotopic, the M+1 and the M+2. So we've got 3 isotopes extracted. So what I will say is that in the absence of interference, i.e. when there's no interference, the more ions you measure, the better. So if you measured a bunch of ions and you're confident there's no interference, you should include those in your statistical quantitative assessment. So add the peak areas up. We've definitely shown this with SRM where there's very low interference. We show that using 5 transitions gives you more reproducible quantification than using the best transition. So so in the absence of interference, so you have to be thinking about what's the likelihood that I have interference here. And so in DDA, when you're using MS1, the likelihood of interference is one of the highest possibilities of all of the different ways of using a mass spectrometer to measure peptides. So using MS1, so there, I think there can be an argument made that, okay, use the monoisotopic only because you're decreasing the probability of interference, because we just saw okay, yep, the interference can happen by something that's one mass unit heavier or lighter. And, so there's just much higher probability of interference than there is with DIA, PRM, or SRM. So I don't have a definite opinion on that, but I can imagine that if there's a case to say use the most intense thing, To me, it would be MS1 DDA. But otherwise, we tend to just sum everything up. What accuracy threshold do you recommend? Greater than 10 ppm? Yeah, so that I showed that data. That was probably when we were doing profile mode extraction, because now typically we would use centroided extraction. I'm going to show you that in our settings when we do hands-on, and we would probably, I guess 20 ppm is the largest that I recommend for extraction, for centroided extraction out of Orbitrap data, which is that's what it was. And we do go as low as 10 ppm, but you have to pay attention to the quality of your data, right? If you're there are some, and hopefully we'll look at that too. There's a way of looking in Skyline and going like, well, what's the distribution of mass error? And if your mass spectrometer was calibrated like 5 ppm off, and then the mass error, the mass error standard deviation is 3 ppm, well, then you might want to be using a 15 ppm. So I have a rule of thumb, which is you should take your mean mass error, and we'll look at this plot in Skyline during this thing. You take your mean mass error and then add 3 standard deviations, and your extraction width should be at least that wide. And we'll see how that holds up for this data set when we get a chance to look at it. All right, so I'm going to stop there for now, and everybody, yes.
Oh, if I could just clarify one question really quick.
Okay, go ahead.
A couple people have been asking about the installation for MS Stats, and that will be useful if you're doing some of the processing that we start today overnight. However, if you do plan to do that, some other R packages are required. So just take a look at those questions that have been answered in the Q&A, and I point you to where to install MS Stats and all of the other R packages.
Yeah, and I studied what what Ali presented last year, and so I'm going to open up RStudio and do some of the same steps that she did last year to show you how I installed MS Stats, and I did get through it successfully. The version we want to use. I went to a completely pristine machine in a computer in my house that had never had Skyline installed, never had Skyline Batch installed, never had RStudio installed or R. And I went through all of that, got MS Stats installed. And yeah, so I was able to take and then run all this stuff using my home network, which is definitely slower than what I get at the university. So I feel pretty confident that we can get you through these instructions, and I will help you at every step, and then certainly demo stuff for you. So, and we'll be right back. How about let's take a 15-minute break and come back at 9:45. Well, that's me. 9:45 for me. Adjust to your own time. I'm talking Pacific time. You can see my time in my on my screen. But I'm gonna step away, and everybody else is invited to step away as well. Hello, everyone. Our 15-minute break is up. And we're going to start the hands-on portion of the presentation. I'm going to switch to a computer at my work inside, at University of Washington. But first, and I'll show this page. Hopefully everybody has gone from the May Institute page, documents, and gotten to this page, and hopefully everybody got through installing Skyline Batch, RStudio, and installing R 4.0.3 at this point. And we're going to switch our attention to this Bruder data set, which we've been talking about as part of this paper. I think it was a real turning point paper for DIA in 2015. Now 7 years old. But we're gonna reanalyze the data with Skyline. The original analysis was done with Spectronaut. And so I'm gonna switch to my work computer to do that. It's a little bit more powerful than my home computer. And so here again, this is the page that we're focusing on. And if you got through these first steps, then the next thing to do would be to click on this link, this top link, and this brings you to a page from the paper. We have now published to Panorama Public the two data sets that we're teaching here, and this is the Bruder one. And we did our best. We worked really hard to try to document this as much as possible, so that, like, in theory, I should be able to just go, okay, well, over to you. Why don't you just read all this stuff and work out how to run all these things, because it's really thoroughly documented here. But I know from experience that having me talk you through it, it helps a lot with learning. So there's a lot, you can come back here, read this stuff thoroughly, and get to the same point. We even have the slides that we presented last year, which are slightly modified, or not quite exactly what I just presented, but very, very similar. And then I'm going to present a set of slides that will be like Ali's when we get to actually working with Skyline Batch. But we asked you to download this BCFG file, and if you did that, you would and then we asked you to, so this is, you would end up in Skyline Batch with something like this, where there's these two configurations. One's called Bruder and one's called Bruder MS Stats. And the one, so that they're very close to each other. And I'm going to show you how to create both of these yourself later. But we asked you to just run the download files only. I guess now we'll go through that later, because what we're gonna focus on actually building the template file. So when you run a Skyline Batch, and when you do any sort of DIA analysis, you want to create a template file. You want to create the file that describes what you're going to do in terms of processing and extraction. So so that's our first task. But in theory, everybody would have, or ideally everybody would have this. So I did it in my documents folder. I created an NEU 2022 folder, and inside that, I created this 2015 Bruder folder. And you can see here's a fully processed one that we're going to look at. So I've done this multiple times. And then here is, if you had downloaded the BCFG file, open it in Skyline Batch, and just click the download data only, you'd end up with something like this, where a few little files have been downloaded, and here's the 24 raw data files that we would ideally like to process. So that's that's what we hoped everybody could get through. Again, on a completely separate machine in my house with slower networking, I did manage to get through all actually the full processing last night with MS Stats and everything. So I know that it's possible. So with this, there are some extra files from that folder that we still need to. We're gonna do this more from the perspective of, okay, like, so we could just run everything with BCFG, with this BCFG file, and then we would have a complete, you know, this would have, you know, that's basically what I did here. This is, oh no, this is actually, this is fully processed with my own processing. But I have definitely run everything with BCFG, and you get, you know, absolutely everything completely processed on your own machine. But what we're going to do is we're going to do it as if we were trying to set this up for ourselves the first time, as if we didn't have this BCFG file. Okay, so the first thing we need to do is create a template file. So that's all your settings and everything you're going to target in one place. And that's actually in this PDF here. So I'm basically going to walk you through that PDF. But before I do, we're going to go to the files directory, and we need this library and the reports. Do we need anything else? That's all I can remember at this point. Okay, so let's just get library and reports. And we're gonna download those. Is that it? Yeah, I think that's it. So get the library and the reports, download them by clicking this download file. So we clicked files, checked library and reports, and then click this download button, and then you can see that this zip file shows up at the bottom. And I think I could just click to open it. That's not really what I wanted to do. So I'm going to go back up to downloads, where I can see the file. So if you haven't clicked on it yet, you can say show the file. There's another way to click on it to show the file, but you basically want to get into your downloads folder with the zip file showing, and then you right click on the zip file, and Windows will offer you the option extract all. That's what I'm going to do. And then I'm going to browse to right here. So if you've, you know, created some folder, so this is my NEU 2022 folder in there, and then my Brooder folder, I'm just going to extract right into the folder that has the raw data. So it should have a raw subfolder. Now, I guess if you did not, so let's actually, let me pull back for a second. If you didn't get as far as running the download files with Skyline Batch and everything, you can catch up by simply, you know, going to your documents folder, creating a subfolder or two, and then, yeah, you can now create a subfolder and just go, you know, my Brooder. So if you want to, like, I think that you should still be able to follow along if all you do is create a set of folders that are raw. And then the trickiest one is you have to have this Brooder ppm. So I'm going to copy it from here, but you would go into my Brooder, and then you'd want to create this new folder and call it Brooder ppm 15C RT10. And that's just specifying that it's going to be 15 ppm centroided data with a 10-minute retention time window. So if you have a folder and those two subfolders, then you should be able to follow along with the rest of this. So so let's go back to our downloads folder. Where is that? Oh, I guess that. So if I go back to my downloads folder, right click here and extract all. Then and then I browse and I want to find a folder where I have this raw and this Bruder ppm 15C RT10, and that's where I'm going to extract everything out of my zip file. So extract. Okay, and so now it's, Windows pops up this window showing me where I just extracted to. I have a library and a raw. Oh, I have a library and a reports here. And you can see actually reports has this Bruder annotation CSV, which we're going to want. And we also have a copy of it up here. So if you ran download data only, you got this .sky.zip and this annotation CSV, and you got some folders created for you when you'll have the raw data. Okay, so but now let's go ahead and wow, my video keeps stopping. Huh? I get frozen. So now let's go ahead and start doing the steps to create a template. So to do that, we're going to start Skyline.
Brendan, one really quick question.
Sure.
I think people are confused about where you got the zip file. Could you speak to that one?
Okay, so the zip file comes from, again, we up on this. So from here, we can click on this, right? Download and publish data from Panorama Public using Bruder BC. So that thing, you can click on it, go to that page. On this page, you click Files, and then you just check Library and Reports and click Download. And then now if I go to Show in Folder, I have a second copy of this zip file. So that's where we got that. And then you right click on it, extract all. So that's it. So now going back. Okay, so did I start Skyline yet? No. So I'm going to start Skyline. And I've already been through some of this. So actually I'm going to go quickly. Usually I think to do this ahead of time. I'm going to go to Tools Options, and I'm just going to reset my, since so many of you have never used Skyline before, I'm going to clear all my saved options. It's definitely better not to have, Skyline will offer me all sorts of help. Okay, so now it says, what do you want to use Skyline for? Proteomics, molecules, or mix? So I'll accept proteomics. So first time into Skyline, so this just clears out all the options I may have saved from doing this before. And we'll go to blank document. And actually, if you have used Skyline before, then the first thing, the first thing we should all do anyway is to go to File, Open, and then inside this Bruder 2015, where we go to the Reports folder, there's this MS Stats Annotations file. And it's an empty file. All it does is get certain annotations and reports that we need from MS Stats, that we need for MS Stats into Skyline. So go ahead and open that. You can see you don't get anything, but it does say Skyline MS Stats annotation is open. The settings that we're getting are in document settings. We can see that there's a couple annotations, condition and bioreplicate that MS Stats needs. And then there's these two reports, MS Stats Input Plus. And this one, MS Stats doesn't need, but we use anyway. So that gets you all those things. We don't now need that. And so the next thing to do is to click New Document and then reset the settings. It's already checked, but still you want to just say Settings Default. Yes. Oops, no, Settings Default, no. Settings, you don't want to save the settings. And then I also tend to like to then bring up the audit log and prove to myself that this is an empty audit log. So I'm gonna go ahead and keep this audit log open. This tracks everything that I do in Skyline, and would, we hope, be helpful to somebody who wants to recreate this document later. So it would provide a set of instructions for them. So we can see that grow as we do these steps. So let's save this file as, we're going to put it in the Bruder root directory where there's no files right now. And we're going to call it Bruder 2022. So just save it to the root of the folder where you have the raw data and the reports and the library and everything. So that we just have an empty document with default settings, no audit log. This is like just a great starting point. And then we're going to review all the settings. So we got peptide settings, transition settings, and document settings to get through. For the most part, we can accept defaults. So we're fine with this as defaults. For the data that we're going to be working with, yeah, we're not going to start with a retention time predictor that will get created by virtue of what we do later. And we're so here's the first place we're going to make some changes. We're going to say a minimum of 6 amino acids and a maximum of 55 amino acids. And these are just values that I've learned from looking at the assay library that came with this paper. So I'm just trying to reconstitute what the paper did inside Skyline, and then 0 excluded amino acids. And then the library, we're not going to create a library right here. That will come later by virtue of this assay library that we're going to import. And so the last thing we want to do is make sure that we support all of the modifications that Spectronaut used. And again, I know this just by looking at this data and going through and ending up with errors at times importing this thing. So this is stuff that I derived, but I'm not going to go through how you would derive it. The first thing we want to do is we're just going to add structural modifications. So click Edit List and then Add. And the first thing we're going to add is oxidation. So you can just drop this list and press O. And then there, oxidation on methionine is what we want to choose. And then OK. And then add, again, drop this list, and you can just see at the top acetyl end term. So that's the acetylation at the end terminus of the peptide with no amino acid specificity. And click OK. And then the last things we want to add are water loss and ammonia loss. So add, and we can scroll down to the bottom and see water loss. Add, and then add, and we can see ammonia loss right at the top here. So you just choose. So you want your list to look like this. Should I imagine that I may be faster than people? Is there, yeah, I guess do I have a poll that says, is it okay to move on? So I'm going to wait a second, and then we'll just see whether people need more time or need re-explaining. So I'm going to launch this poll. And people can vote. Oh, is it okay to move on, or are people like, people stuck? No, need time, need time. So yeah, well, that's great that a lot of people are fine with moving on.
That was just a quick question again about how you're using methionine oxidation. I'm guessing it's just a variable, but Mark wants to know if it should be variable or static.
Oh, variable, yeah. So by default, everything comes, yeah, like by default, they come up the way, yeah, you don't have to change anything. You just have to choose them. So, but yeah, so by default, these will be variable modifications. So there it is, variable. Okay. So I'm gonna, what does MS stats do? Yeah, we're gonna get back to that. Okay, so there we are. It seems like most people are okay. I don't know whether people can revote. Is that a thing? Whether the 7 people who say they need more time can start saying, no, actually, I am okay. I don't know. But I'm going to go ahead and end the poll. I guess people that if I end, people able, oh, I have to share the results. I don't know. Okay, so there are the results. It's more for me to know whether you're ready. Hopefully I can give that poll again later, but I'm glad that so many people are, so many people are actively, we're still up to about 60 people actively sort of going along and responding. So that's great. So let's click OK. And then you just want to check all of these like that. And that's all you need to do on this page. And actually, we're not going to be doing quantification inside Skyline, so we can just leave that blank by default too. So when I click OK, I'm going to get my first audit log record that just, you can read it and see, oh yeah, it's just summarizing everything we just did, which is not very much. So then let's go to transition settings. And all the prediction, we're just going to use monoisotopic prediction. The other option is average. And the rest of these are pretty much for targeted acquisition. So it's whether or not, how you want to specify collision energy. Declustering potential is a thing on SciEx instruments, compensation voltage on thermophanes. But so none of this stuff applies to this experiment. So we just skip it. And then on the filter, it turns out that, the Biognosis folks were very permissive and used, 1 through 7 charge states and allowed product ions. So if we were not this permissive, which, I'm usually not this permissive in my experiments, but if we were not, in this case, when we imported the assay library, we would get a bunch of errors because it would say like, oh, I can't interpret this. There's nothing with this precursor MZ that I can interpret that fits within the charge states that you've given me. And then we're going to go Y, B, and P. We're going to allow all of those ion types. P is for precursor. And then we're going to turn off this special ion N-terminal of proline, and we're going to just allow all ions. So pretty permissive settings in the filtering. And that's just what we're trying to import somebody else's library with as few errors as possible. So then in the library tab, we don't have a library yet, but we're going to have a library based on the data that we get from Biognosis, from their assay library. And we're going to add an ion match tolerance of 0.05 MZ, which is a good tolerance if you're actually dealing with real peaks that come out of an orbit trap. In this case, you know, all the peaks in our library are specified by their true MZs in this diagnosis assay library we're going to import. But we'll go ahead and this is, you know, if you're doing white-res mass spectrometry, this original default value is really for ion traps. So 0.05, which is more or less 50 ppm, pretty wide tolerance even for orbit traps. And then we want to say that we're going to take 6 product ions. We would like to have a minimum of 6. So we're going to just force this to be like, we're only going to measure things if we have 6 product ions for them. And that's a typical setting. So that's that tab. Moving on to the instrument tab, we will say the minimum MZ is 300. And that's how we cut out some of the really small ions. You know, over here in filter, we said we'd go from ion 1 to last ion, which means Y1 and B1 are allowed, but they will not be 300 MZ. So this is really kind of pushing us up to larger fragment ions. And then the range goes all the way up to 1800. And then the rest of these things we don't need to set for this data.
Brendan, there's a question from Tuoli that says, why not use ppm for ion match tolerance?
Why not use ppm, this ion? Oh, ppm. Yeah, that's a good, yes, right. Yeah, that's a good idea. Why? Just because that's not how, you know, we started with ion traps and we haven't fixed it. But yeah, that does actually become an issue when we get to this full scan tab. So let's move to the full scan tab, and then on the full, and I'll explain why we would, you know, why more and more I would like to be able to do ppm there. So we're gonna just forget MS1 filtering for this data, although you certainly can do it and it can be informative. We're gonna use DIA filtering. And you can see that the default now is centroided, which is what we want. And we're going to say that we have a tolerance of 50, our mass extraction tolerance is 15 ppm. And so I have seen cases where we're doing this type of extraction and people say like, wait, I can see this value in my library, but it doesn't show up at all in my extraction. And that's because, again, the library has a different tolerance than the extraction. So yeah, I would really like to be able to just say, have a checkbox on here. One, be able to switch to ppm, and another have a checkbox that just says, use my setting over here, same setting, so that you're doing 15 ppm in both places. And you don't get confused by like, hey, I see this annotated thing in my library. It's like, well, that peak is not actually really that close. And so then the last thing, what we're also going to say that we're going to use retention time prediction. And we're going to use a 10-minute window, 5 minutes on either side of our retention time prediction. And you'll see the retention time prediction comes from the assay library, and we'll see that in a second. So then we need to choose an isolation scheme, and there's nothing here that exactly matches our data. So I'm going to click add, and I'm going to name it 19 variable. So this is a variable isolation scheme that I think the diagnosis team came up with for an Orbitrap, probably a Q-exactive instrument at that point. And we're going to use pre-specified windows, which allows us to just know more about the data up front. And after doing this a lot where people would send me a data set and we would spend time trying to figure out what it was, the isolation scheme. I made it possible to just import. So you click import, and ideally for anybody who actually has, hopefully there are people who have raw data files, and maybe we'll just come up with something. Yeah, if you don't have raw data files, I don't know how many people have raw data files. So I'm going to double click on a raw data file to import it, and that will give me the isolation scheme. So if and then I can graph that to get a sense of, you know, if there were any gaps or single cycle overlaps, if there are any problems, they would show up in red and yellow, and there are no problems. And then the one thing I can see is that there are these margins, which we talked about yesterday. There's this little bit of overlap that we're going to ignore. So Skyline's going to treat it like our isolation scheme is like this. Those are considered the extraction windows, but the measurement windows, the things that we actually measured, included a little bit of overlap, and that helps us just avoid those signal loss ranges. So I'm going to close that. That all looks good. I guess let's try the poll again to find out, was everybody able to get those 19 windows? Do enough people have raw data that was possible? All you needed was one raw data file out of that set, but you did need that. So let's check. Can I restart that one? Poll ended, untitled poll. Can I relaunch poll? Okay, here we go. So, okay to move on. And that basically means like, yeah, I have this isolation scheme. And if you're like, I don't have the isolation scheme, then you're not okay to move on. And I guess what I'm going to try is I can select this isolation scheme.
There's a request from Paul to see if you can repeat how you created this isolation scheme from a raw file.
So I clicked import and just pointed at the raw file. So you just go find one of these raw files that are all, you know, in the middle they have sample 1 RO1. So MRM, MHRM, T0. I guess it's all T0. Yeah. So that, and then I just opened that. And that created this isolation scheme. So there's some people, I don't know whether, you know, it, like I told you that if you hadn't downloaded anything, you could create MyBrooder and just create a raw, but then you won't have anything to import. So if you didn't get to the point where you actually downloaded some raw data, this might be a challenge. But you should be able to, so let me see what happens if I paste that into the chat. Whoops. Can I do that?
Can you paste it as an Excel sheet, maybe?
Yeah, I guess. Oh, I know what I could do. I could go to the could go back to this. And why isn't it? Yeah. Oh, why is that? Nope, it's not working. I don't know why Control C is not working there. So, yeah, how would I get people this? isolation scheme.
Could you also just like save this document and just share it
Yeah,
at
that's
this
a good.
stage?
Okay. Sure. Just a second. I will. Well, we're almost at the end. This is like everybody can download the template, and so this is just creating the template. If you don't get here, you can download the template, and that will be it. So I think we're going to move on, despite having, and I will rethink this in case people don't have raw data. One thing you could do is you could go back to this Panorama public files, go into raw files and just download one of these. They're big, 2.4 gigabytes, which is why I was hoping everybody would be able to get one overnight, but you could just click and download one. And that when you have one downloaded, then you could do the import. But I'm going to keep going. Okay, so this is, and I mean, it's, I guess, follow along. I mean, you can, if you didn't get that created, just choose any one of these, maybe what results only with a 0.5 margin.
Okay, I just tried. Silas Bosk just shared the scheme on the chat, and
Okay.
I copied it and pasted it. But you have to make sure that specify margin is ticked in order to allow to paste the 3 columns.
Right. So you could, yeah. So what he's saying is pre-specified windows, and then you have to check specify margin, and then you should be able to just paste that into there. You want to put your, you see this blue, and then you just say Control V to paste in something that somebody else has supplied. And a final option would be, and I think this would work okay for this tutorial, is you could add and just go pre-specified with 1 MZ margin. And then, so isolation width is taken from the results. Results with margin, and then you get to specify the margin as 1, and there's no deconvolution. So this is another isolation scheme that would work for these data. It's results only, edit current results. It's not pre-specified. So this, I tend to really prefer having the pre-specified, but this Skyline will correctly read the information. So I'm going to switch back to this, but in a pinch, you can do results only with one MZ margin is what the data has. All right, let's click OK. So we're done with our done with the transition settings. So there you go. I got another more extensive entry into my my audit log, all the transition settings I changed. And then I'm going to go to, we're going to import the assay library. So you go File, Import, Assay Library. And then we should be able to go to the library folder that we unzipped, and you'll see 2 CSV files, and we want this. This was part of the supplementary data, this MCP profiling CSV, and we click open for that. And Skyline will bring up this nice form. This is new in 21.2. We get this, or maybe it was 21.1. We get this nice summary of what it is we just imported. And you can see that there's a bunch of, this is the full CSV. There's a number of columns that Skyline's just ignoring it at this point. And we could just hide those. And then now you can see that this is the modified peptide sequence. the protein name, a protein description, precursor MZ, IRT. So this is our retention time. And then, so precursor fragment is the transition that Sue was talking about that we're going to be using. So these are the transitions. And you can see that each peptide has more than 6 transitions. So some of them have, this is like maybe 9 transitions. And then we have what we're calling library intensity, what the diagnosis teams calls relative fragment intensity. So, and you can see that each, I thought they each had yeah, so a lot of them have 100 as a fragment intensity. And so it's basically relative, where 100 is it's all normalized to 100. And then these are the IRT values. So we can click OK. And in this case, we're going to get more errors than we would like. And we would have gotten even more errors if I hadn't gotten the modifications right and everything like that. At this point, we still end up, however, with 330 transitions out of hundreds of thousands. But we still have 330 transitions with errors. And not this first one, but if we start scrolling down here, you can see that there are a lot that are 400 point something. And I guess if you use the results, you wouldn't see this, because we don't know. If you use a results only thing, we don't really know what the range is of the. So you would not be getting these errors if you did results only. But with a pre-specified isolation scheme, Skyline is saying, hey, wait, this 400, that's not in your extraction range. So we're going to go lie to Skyline a little bit about what we actually did for the experiment, so we get rid of some more errors. So let's go ahead and cancel out of here and cancel out of here. And then we're going to go to transition settings. And we're going to edit our isolation scheme. And we're just going to change this from 400 to 399. So we'll pretend that we extracted from 399 to 430. And that means that this margin of 1 will allow us to include anything above 400. So this is the kind of, sort of tweaking I do frequently when I get something like this, when I get one of these assay libraries. So now we'll go File, Import, Assay Library again, which again is just a big CSV that Skyline analyzes and will show us. I don't know why it's taken that long. So there it is. And yeah, and so we've made a fix, and this is, frequently I can get these things to have no errors at all. This one actually has some errors, and I'll explain that, and then we're just going to move on, because out of hundreds of thousands of transitions, we're ending up with 89 transitions with errors, and the majority of these are, you can see, are peptides beginning with a methionine. And what's actually happened is this is a peptide where we have both methionine oxidation and acetylation on the N-terminus. And we would have to define another modification for that specific thing to allow these not to have errors. And I just don't think they're all that likely anyway. And so anyway, so we're going to choose to just OK and keep going. Oh, I didn't check for errors. Now I got to do it again. Okay, so now we're building the file. And oh, wait, it shows us these errors again, but we just ignore them. And now it says, hey, do you want to just use existing IRT standard? And we could choose this Diagnosis 11, but what we're going to do is we're going to use a separate transition list. So browse, again into library, and then we have this diagnosis IRT CSV, and click OK for that. And then OK. So this is just telling us telling Skyline how to calibrate those IRT values. So we had a bunch of IRT values in the assay library. This includes the calibration information as well as the peptides that are part of the IRT standard. So now it's creating a spectral library to hold all of this stuff that we've just told it. And then we get, oh, now it's got to re-update that document that was built to match the spectral library. And then we get all these lists, which are actually proteins. But yeah, so there's a bunch of peptides. You can see that the audit log just says, hey, I imported this CSV file, which actually I think it should also contain the IRT CSV that we added. So, but the point of this audit log is just to tell you how to reproduce what I did. But yeah, so now you can see if you click on here, that you get these library spectra. They're very clean library spectra. They only contain the ions that were part of that CSV. And you can see that some of them contain like B5 minus 17. So that's an ammonia loss, right? So there's some losses here. There's some very short peptides, you know, and this one has 2 loss ions, Y4 with a water loss and Y5 with a water loss too. And so all of this information that was in the assay library has been pulled into Skyline. You can see that we have 242,000 transitions. We lost 89, but we got quite a lot in, and it's certainly valid. And so now let us, the one last thing we want to do is, because these peptides have more than 6 transitions. We were aiming for 6 transitions to do our analysis. At this point, we have more. So the library we used is more extensive than what we necessarily want to target. So we're going to go to Refine, Advanced, and we're going to say minimum 6 transitions per precursor. So that means we're just going to throw out any precursor that has fewer than 6 transitions. And we're going to say auto select all the transitions, which is going to reduce these numbers down to 6. So pretty much once we click OK, which go ahead and do because it'll take a little while. In the end, all peptides in this document are going to have 6 transitions, with the possible exception of the IRT peptides, which are our standards. And but yeah, so you can just see that over here we lost transitions, and we have 6 now. And then again, you can see that the audit log, you know, that was a pretty extensive change. We went from 240 transitions to 175, or 240,000 to 275,000 transitions. That reduces the number of chromatograms we need to extract. And you can see, again, Skyline is just reporting what we did rather than trying to sum up like, well, we threw out all these individual transitions. It's just trying to record steps that would allow you to go back and do this again later, which can be really useful when you publish your data for a paper.
Sorry to interrupt you. Just there was a question to see if you could show again how you did the refine and what was chosen in there.
Yeah. Okay. So refine.
There's one, and after that, there's one broader one as to how do you generate assay libraries or spectral libraries.
Yeah, so Spectra. So hopefully tomorrow we'll go through and we'll go through a case where we actually build the spectral library inside Skyline. This is a case where we're going back to a paper. And ever since I started Skyline, I've always been very interested in both supporting, hey, start from scratch, like do my set of steps, but also like, wow, I found this analysis in a paper. I want to be able to analyze it with Skyline. Because obviously when I started Skyline, there were no analyses with Skyline. So I had to put a lot of effort into, exporting transitions for a triple quad, but I also wanted to be able to go back to older experiments where the data was already collected and review them. And we still put a lot of effort into both sides of the thing, where it's like, here's how you do it natively in Skyline, and here's how you get something from somebody else. But I recognize that, yeah, a lot of people are like, well, what if I don't have one of those CSVs? Well, then you would do something very differently. And the thing that we would most hope would work for you would be to go to File, Import Peptide Search, and then you would say, hey, I'm doing a DIA experiment, and you would walk through this set of steps where you gave it search results, which when you click on it, you can see that Skyline offers a lot of possibilities for search results. So this would be your own DDA data. You could have a .dat file, pepxml, blah, blah, and so you would build your own library, and you'd never deal with this CSV file. But the CSV file is how we take something from another tool. So hopefully tomorrow when we get to CelebSec, we'll actually build from scratch. But this is just a nice way to go back and look at somebody else's data and get a sense of how Skyline processes these files. So, but yeah, I'm sorry that this isn't a start from scratch example. Okay, so the last thing we want to do for this template, you'll notice the template doesn't have any decoys. It's really just what we want to measure and the settings to measure it. And then the final thing we want to go to document settings, and we want to click these annotations, and we want to check MS stats and so these are two reports, and then these are the two annotations. So, and then I'll show you. So hopefully everybody's got that. Annotations, just the two that we imported before, and then these reports are the two that we imported from at the beginning. We opened up the file, and that gave us these things. So click OK. And then if we went to view document grid, so document grid is a way to see reports live while you're working with Skyline. You can see that it comes up with this protein report. We can see all 3,866 proteins in our document. And you can, again, with sort of directed investigation, you could click on this or click on any one of these, and it will select the protein over here. And if we switch to replicates, well, we don't have any replicates yet, right? We haven't imported any data. So, but you can see that I have this annotation, condition, and bioreplicate that I could fill in on every replicate, and that's what the MS Stats needs. It needs a condition and a bioreplicate in order to do the analyses that it's going to do. So, and we're gonna fill that in with Skyline Batch. So we're going to import a bunch of data, and then we're going to specify the condition and replicates of that data using Skyline Batch. We're going to do everything else, all the other processing with Skyline Batch. We just need this template, and you're done with the template. So click Save. And that's it. You can just close down Skyline. Maybe we'll close the audit log and save again, because Skyline saves your window layout. So that way, next time you open this document, it won't show you the audit log. But that's it for that. I'm going to take a 5-minute break, and then we'll come back and look at Skyline, and we'll set up the Skyline batch processing part of this. Okay, so 5-minute stretch, potty break for everybody, and we'll finish with Skyline Batch. So great, thanks. And I mean, I think other people may stay around and answer questions. I'll be back. All right, we got a couple minutes, but I think I'll just answer a few questions. Somebody asked about the eye mobility settings. We didn't use any eye mobility. The eye mobility settings would be for if you did DIA PASF or DIA with FAMES. So yeah, we didn't need those, and that would be a completely different subject. And there is a tutorial on DIA PASF, and that would be the best place to look for more information about those settings. Mass errors, do these ever point to non-specific post-translational modifications? Yeah, that would be more of a peptide search question, I think, at the point that we get into targeted. Yeah, that's not really something I can answer. People in our lab measure DIA product ions in profile mode. Is this in any way beneficial, or is centroided sufficient? Yeah, good. That's a good question. At the McCoss lab, if you're using an Orbitrap, we no longer even really save the profile data. So if you acquire in profile mode on an Orbitrap, then the raw data file contains both the centroids and the profile data. And so our files are much smaller if we do only the centroided data, and we're not finding that the profile data is all that useful to us. But certainly, even if somebody acquires in profile mode, that just means they're saving the profile data. You can always get at centroid mode data. So we highly recommend that you use the centroided spectra in the analysis. That's definitely been proven over and over for us with Orbitrap data. Use the centroided data for analysis. But up to you whether you want to devote the disk space to saving the profile spectra. So that's that. but yeah, a lot of people at them in McCoss lab frequently do not. Is it feasible to use Ryzen CPUs with Skyline? Does it make a difference compared to Intel? If it can run Windows, it should be fine. I don't have a direct comparison myself. But if you want to do one, we'd love to hear about it. Does considering AI-ions help in IDs? Only if you expect AI-ions to be there. So I don't know what produces the AI-ions, but we've never done that. So I can't really answer that one. How should we adjust to see, for example, only 6 best peptides for each protein? That's a good question. You would need some way of deciding what the 6 best peptides are, and so typically we would do a round of refinement, what we just talked about, and then once we had imported data, we could choose the 6 most intense peptides for each protein. That's another refinement when you have imported data. Otherwise, you would need some sort of score to differentiate them, maybe something like the Prozit team would come out with or something like that. But at this point, yes, there's a bulk way for Skyline to say, like, okay, if you've acquired 20 peptides and you did an experiment, you measured all the peptides, then you could tell Skyline, okay, only take the 6 with the most intensity. And that's the way we do it. So that's very, very possible. All right, so I think most people ought to be back by now. I'm going to stop answering questions and get on with Skyline Batch. So I got to open the presentation for that. All right. So this is, thanks to Ali Marsh very much for creating Skyline Batch. The goal is to make it a user-friendly tool to run simple automated Skyline workflow on many files at a time. So it's not an extensive workflow manager. There's a particular workflow that I found really useful. I used it on a bunch of different experiments, and I'm going to present some of how I used, or I didn't use it. I used a set of batch scripts that I created. So and then I used the same workflow that we then put into Skyline Batch, which I'll present in a second. So it's great for comparing different settings, quickly getting from Skyline template to a full report file. So and then processing that report file with R. All of that is supported by Skyline Batch. And then it's great for overnight processing, where you can just do really extensive processing that you just would be out of the question, or just weeks of work if you were to do it manually in the Skyline UI. So this is the workflow. Hopefully at this point you've done the download of the data, tried it. We just created a Skyline template file, which then Skyline Batch will copy to a new folder for analysis. So we never alter the template file. We make a copy of it and then continue from there, which makes it possible to do 10 different variants on the same template to see how you get the best processing. We import the data files, and then at this point we could create a new refined file, and then we could take that back and do another round, which is not really shown here, or we could export a report either from the original document or the template the refined document, and then at the end we can run our scripts. And this workflow, although it's pretty simple, is extremely powerful. And hopefully you'll get to see just a little bit of that here. And you can read the paper for more details. So the genesis of the batch scripts, so they were written batch scripts, Windows batch scripts, .bat files, came when we started in 2015 on this DIA swath software comparison led by Pedro Navarro while he was in Stefan Tenzer's lab. And the outcome was this 2016 Nature Biotech paper. And I have to admit that Skyline was not well suited for this particular analysis when Pedro started, and he reported, that he, even on it was, so the comparison pipeline, so we got things to be 20 to 200 times faster. He was not able to do it on a spinning drive, and even on an SSD, it took 5 hours with Skyline 3.1, a pretty old version of Skyline. And then by the end, we could import all 6 files in 50 minutes, which I think were quite a bit faster than now, on a spinning drive. So whether or not you're on an SSD or a spinning drive was no longer very much a big deal. And adjusting all the peaks took 2 hours in 3.1, and we got it down to 10 seconds in 3.5. So lots of performance improvement and improving the software thanks to somebody just coming and saying, hey, we're trying to do this. It doesn't work very well. And then we get to work with them. And then Skyline looked bad for the initial, like 2015. These were the numbers. They got presented on a phone call, and let me say that all the tool developers were on that phone call, and some of them really wanted to see these numbers published as soon as possible. But we were like, hey, wait, why are our numbers so terrible? And so what a technique that I've used again and again is okay, I think I just froze for a second. Hopefully I'm back for you. Thankfully, as Lindsay pointed out, Spectronaut has some visualization as well. So I just looked for the peptide where Skyline was giving it a really terrible score and Spectronaut was giving it a really great score. And I went like, well, how can that be? I mean, they work very similarly. Why would a peptide be just terrible on one and great on another? And it turned out that, when I looked at these chromatograms, and again, being able to zoom in the chromatograms is extremely helpful. I could see this same peak. Yeah, this looks, this is a pretty good peak, but there's a lot of interference that Spectronaut just wasn't even seeing. And this interference was so bad that Skyline didn't even detect this as a peak. It was, this thing somehow, and then this was the best thing with the best coelution it could find. And so that was totally wrong. And that turned out to be because of a confusion with Pedro and me on the phone, where he said he was going through the settings and he said, okay, so 10,000 resolving power. And I thought, well, the data, you collected the data, sure, whatever, however you collected it. And that ended up using an extraction width that's really wide. And he actually used 30,000 resolving power. And at the time, Mike and I felt like, well, you really want to try to include the whole peak. So we thought this would be these 30,000 resolving power is what we would have suggested at the time. But after looking at these data for quite a while, we found that actually, even when this is a 3-organism mix, it's highly complex data. Again, there's that risk of interference. And so even with profile data, we found that 60,000 resolving power worked better. So just doing basically the full width at half max of the peak rather than the full width of the peak, full width at base. And then what we found worked even better was plus or minus 10 ppm on centroided data. So that ended up being the thing that we went with that experiment. And the way I got there actually was, I started out, pushing data through Skyline and realizing, whoa, wait a second, 30,000 resolving power is way better than 10,000 resolving power. I could see that right off.
And after talking to Pedro, I was like, oh, you should have used 30,000 resolving power. But then I wanted to just do an exhaustive analysis where I was doing these 5 different resolving powers, and we actually had 4 different data sets. So that's 20 times I wanted to analyze these data in Skyline. And it was just, there's no way I was going to do it manually. So Skyline already had a command line interface, and I wrote these batch scripts that allowed me to go to bed and come back and fill out a spreadsheet that could allow me to see this graph and see that, well, actually it's still getting better up to about 60,000. So, and then I did a retention time analysis also. I actually kind of expected this to once I got the window large enough, the number of detections would go down, but it turned out that detections were really quite stable, even out to 30 minutes window were pretty good, but around 10-minute window there was not a whole lot of improvement after that. So, but again, this is like how many points? This is like 10 points, and I was able to set it all up with a batch script and run it overnight. So I really felt like this, we want to give people this power. And for a while I would teach these courses and go, and here's my batch script. And then I realized, wow, half the people don't even know what to do with this batch script. So that's the genesis of Skyline of Skyline Batch. After the full analysis was all done, the peptide count was a little, Skyline was at the top. There's other metrics here that were of interest, but basically, I think we came away from this really feeling like Skyline, OpenSwath, and Spectronaut perform very similarly, and that was the message in this paper. Recent comparison in 2021, I was approached again. This actually got published to bioRxiv thanks to these like early publication things. I've now seen several papers that looked, like, whoa, what happened? And it's ends up being misuse of the software. But bioRxiv allows us to get them out so early. So this is just this is a summary of these are different acquisition modes with narrow overlap, variable windows, wide windows, and then these 5. So we've added scaffold DIA and DIA-NN from the 3 that, OpenSwath, Skyline, and Spectronaut. And OpenSwath and Skyline look really terrible. And you might go like, oh, well, it's just because they're not keeping up with these other tools. But actually, it was just settings problems. And after consulting both me, the Skyline team, and Hannes Roast on OpenSwath, the results changed to this. And in fact, the authors told me in the end, they felt that the quantitative results of Skyline were really the best, though, the numbers may differ for some of them. But anyway, so that was another, and I used Skyline Batch for this as well. And this is a large scale DIA thing. So let's now go to how to, so we're now going to, so that's Skyline Batch. It's been used, or there's the batch scripts that I created that Skyline Batch should give anybody who can use the UI the ability to reproduce what I do with my batch scripts. They have been used to great effect on these other studies. So let's go back to the machine where we were working, and I'm going to delete this brute. Well, no, I'll just create another one. I don't need to see it. So this, we could, so here is what Skyline Batch looks like when you've opened the Bruder BCFG off the website, and this points to everything on the website. And now we're going to create something a little bit more like you might create yourself, where we point to things that are already present on our machine. So I'm going to go ahead and select this bottom one, delete. So I have an empty Skyline Batch, and you all should at this point start Skyline Batch and make sure it's empty. And actually, before we go on, I promised that we would also look at how to set up R so that it actually can do all the full MS Stats processing. So let's go ahead back to RStudio. So if you got RStudio installed and you got R 4.0.3 installed, then in RStudio you would want to go to Tools, Global Options, and right here at the top it says what R version are you using, and you can see that I tried to I wanted to see how is it going to go if I use just totally modern versions of everything, and I ran into a problem that I'm working with Olga Vitek's team on. But so we realized that, yeah, you really want to go back to, and I'm going to specify an R version here, and I'm going to do this 64-bit version of 4.0.3. So hopefully that's what you installed as well. If you come here and it says your 64-bit version of 4.0.3, then you'd have nothing else to do and you can just wait for the rest of us. But I'm going to switch back to it. And then it says, hey, I'm going to need to quit and reopen RStudio. So that's okay. So you want to see this 4.0.3, then you click OK. And now you have to, for it to take effect, you have to quit. And you can open up in RStudio. So now you have 4.0.3, and for anybody who has not already installed MS Stats, here's how you do it. So when you install MS Stats, you're going to install it into a specific version, and so you need to make sure that you have the version you want in here. Because if you have some other version, you're going to end up trying to install R into that version. So if you had 4.2, you would try to install MS Stats into R 4.2, which is not what we want. So we want to try to install it in here. And what we're going to do is click Open. And then if I go to my working directory and I go to Reports, then I've got this install packages, rpackages.r. And if you open that, now this is good. If you've been following along today, you should definitely see this version 3.2. This is something I had to add last night. So if instead you see this, then go ahead and just add that comma version 3.2, because we want a specific version of MS Stats that is compatible with R 4.0.3. And then you select this first line of text and click Run. And I'm not going to do it because I've already done it. And then once that's done, you would select these two and click Run. And you should be able to get through all the way to where it just, well, I guess maybe I'll do it. I don't think it hurts anything to redo it. Do you want to install from sources the packages with need compilation? Sure. So this is what it looks like when it's installing. This is should actually just be redoing stuff I've already done. And yeah, so that's done. Everything's done. It says, and then I would just go select this and click, and then the currently loaded. For me, they're currently loaded because I'm installing over the top. So I go ahead and restart R. And now it's going to go through all this installation. If you didn't have, so now then it just says it's done and everything's good. So there's no problems. Red text to me is a little alarming, but frequently it's just output. and not problematic. So there, I just went through everything. MS Stats is installed. We're not going to actually do any further work in our studio, so I can close that down and I don't save our data. So that's my best attempt at showing you how to get MS Stats installed correctly on your machine. And if you need more help, stick around and we can try to help you after the rest of the session. So let's go ahead and add a Skyline Batch configuration. And let's see. So I'm going to name it I'm going to name it Brooder 2022 so that it could live side by side with the other one that I have. I have to choose a template file. So, and I can just click ... And if I go to the root of my folder, this is my brooder2022.sky that I created. That's the template file that we created together. So that's going to be my template file. My analysis folder, I click ... and I wish it was starting me where I am. Whoops. So I can just go, I can go to documents. So I wish it chose a better starting folder, but if I drill into my Brooder folder, I can choose this Brooder ppm 15C RT10 folder. And that's going to be, that's my analysis folder. That's where everything's going to live when the processing is done. My data directory, I can then just, and again, in this case, this is where my data lives. And yeah, I could do this. So that, that would give me all my data files. Alternatively, you can see that a lot of these buttons have this button, which means that I want to download this. So let's just suppose that not everybody got all the data downloaded. So let's go ahead and change this to do the data gets downloaded. So you'd click to here, and we're going to add a remote source and call it Brooder on Panorama. And now to get the folder path, I would go back to here. So this, we've been looking at Brooder. So again, if you don't have to do this, if you have all the data downloaded, just leave it on R or whatever. Or if you're feeling adventurous, you can do this. So I click on the files, and then to get the URL for this path, I have to click this top files link. And then here is the folder path, web dav URL. And I can just right click on that and copy link address, or you could drag out a selection and copy that URL. So then I switch back to Skyline Batch and paste that, and it doesn't need, it's public, so it doesn't need a password. So that's my Brooder Panorama remote source. And then in there, I want to get this raw files folder. So you can see below here, back here, we've been copying stuff out of here like library and reports. Well, now we want to focus on raw files. If I double click in there, you can see all the raw files. So that's what we want access to. So we type raw files, and you have to put a slash there. And then we could filter so that we'd only get in a certain set of those files with a regular expression, but we're just gonna use them all, and we can click update. And so there we, okay, 24 files, 67.65 gigabytes. And so, yeah, this configuration, if I click save now, it's set up to download, it's still going to actually put everything in this raw data directory. But if you don't have the data in that raw data directory, then you want to set up this download the way I just did. We need to choose an annotations file, and that's just a spreadsheet that tells us how to annotate all the replicates. And so we have one of those. If you might have one in the root if you actually use the BCFG file to download, or you would certainly have one here in the reports folder that everybody downloaded that at the beginning. So I'm just going to open up that one. And then we want to give a replicate naming expression. So that is just telling Skyline how to parse the file names and extract the replicate names that we want. So what we want for the replicate names, we put an open parenthesis sample dot underscore R0 dot. So remember how we were looking at the names of the files, and we can look at them again right here again behind us. And they all have this sample 1, 2, 4, 5 R0 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's the part of the name that we want to turn into our replicate names inside Skyline. So that's what that allows us to do. And then we can go, so this page is fully filled out. We can go to settings. And if you remember, we didn't have any decoys in our document, so we want to add the decoys. We could do reverse, we'll do shuffled in this case. And then we want to use an mProfit model. You could either use the default Skyline model or the mProfit model. We're going to choose to use an mProfit model. And we're not going to do any refinement. The refinement typically would be, to do another round or so there's a whole lot of things that we can apply to the document once the data is imported, which we're not going to do. And so the last thing we want to do is add a report. So click the plus in here, and we will name the report. Oh yeah, so we just need to tell it what is the report that we want to export. So our Skyline document contains some reports, so we can just name one, and the one that we want to name is that's input plus. Input dash plus. So we'll use culture invariant reports, so that way if anybody's in Europe, that should still work. And we don't need to import the report because the report is part of our Skyline document. We could also specify an external report. And we want to export it from the results file. We don't have a refined file. And at this point, we're not going to run an R script. So we're going to create two configurations, just like the Bruder BCFG file, one that runs an R script and one that doesn't. So go ahead and click OK, save. So here we have our Bruder 2022. And now we want to go back, we want to make a copy of that and add the R script. So that way, because now this way, if I go run all, it'll run everything except for the R script. And so then so I have control over whether I want to run, because MS Stats is the longest part of this. So running MS Stats takes the most time. So let's go ahead and select this one. Somebody raised a hand. Is there a question? Anything? Anybody have anything setting need to be taken care of? If you know, so yeah, there's nothing special that needs to be done for it. Yeah, so we don't need to change the, if you have MS1 scans, Most people do. At this point, we're just ignoring the MS1 scans. You could adapt the Skyline template to pay attention to the MS1 scans. We can talk about that afterwards, but I'm going to keep going here to end this session with creating a copy. So now we have a copy, and we're going to change its name and call it, just put this MS stats, whoops. Put MS stats at the end. You can see that it's actually changing the analysis folder path. So we got to go back and re-choose the same analysis. So this is really the two ways of doing the same analysis, and Skyline Batch will skip over the parts that are already done. So we could run the full analysis and then we could run the MS stats part later. But so the thing that we really want to focus on here, you can see that all the settings are the same. We still have this reports thing. So let's edit the report. And now we're going to apply an R script to it. And the R script we're going to apply is we can just click. So I got there by clicking plus to apply the R script. And we could download an R script, but we're going to just go to, again, in our reports folder, there should be this MS stats brooder, which is an R script that Ali wrote to apply MS stats to the brooder data. And then we need to make sure that we use this 4.0.3 because that's the only version on my computer that has the MS stats I need. So that's the way your R script should look. And click OK. And so now, there we go. Now it says, hey, I'm going to use the MS stats input plus report. I'm going to run this R script on it. And I can save that. And now I have a second one. And so that means that if I want to run just the analysis, I can do this. If I want to run the analysis with MS stats, I could do this. I can also run the analysis with MS, without MS stats. And I was going to start that off while I'm talking. So this is this is the analysis without MS stats. And so you now should be able to do this on your own thing. And it is skip the downloads, even though we said, hey, you could download, it skipped the download because it has recognized that we've got all the files. And so here it's already doing the chromatogram extraction. And you can see it's doing 6 files at a time, and it's going to march through this. And it should be able to, I think on this computer, it does the full analysis of 24 files in about 20 minutes. And we can go back and look at that, and we can switch to the completely processed folder in a second. But yeah, you can see that it didn't do any file downloading because it found that all the files it had were present. All the files it needed were present. But if you set yours up with the download the way we did, and some of the files were not present, then you'd be watching it doing download right now. And so I encourage everybody, hopefully you made it through all of this and you can get through the MS stats version tonight. I'm gonna ask you tomorrow morning how many people made it through everything and got brooder processed. It may be slow with a whole lot of people trying to download these raw data files, but hopefully some people got through that last night. So not everybody's going to be trying to download at once. But I'd like you to try to get through this. If you did not follow, if you were not able to follow along with setting up this Skyline batch, you can always go to this brooder folder and set up Skyline batch by downloading brooder BCFG, and you can run everything from in there. So that is, yeah, that's the end of that. And I'm gonna, I'm only 5 minutes over. I'm pretty proud of myself for making it through all of that without Ali's help. She was here to help last year. And I will stick around for a while to answer questions, either about any of this, helping people set up R. Hopefully Deanna will stick around, anybody stick around. Yeah, I'm going to be here. So as I'm assuming that many people will have to go because this is over the end of the scheduled time. But ideally, lots of people will come back with the data fully processed tomorrow. We'll ask about that tomorrow. So I hope to see everybody back tomorrow, and I'm sticking around for questions. I'll start answering some of the ones that are already up there. Okay, so yeah, any setting need to be taken care of to acquire DIA with MS. Yeah, so we didn't do anything. So I can, even while this is processing, I can go to Skyline. I can start another instance of Skyline. It may be slower because this machine is actually doing a lot of work at this point. But if I open this up, this is my template file. And one of the ways I could have set my template file up, but chose not to. And I'm, in this teaching setting, I'm choosing, I was choosing settings that gave me a smaller document, 175,000 transitions. Certainly I processed documents with over 1 million transitions. But in the teaching setting, it's better to choose small because it processes more quickly. So, but if we went to transition settings, if you have acquired MS1 scans, you're always free to do extraction from those. So we could say, yeah, we're going to do centroided with 15 ppm. We could do that, and then you'll notice that yeah, we already have the P as the precursor. So if I did that and clicked OK, this may take a little bit because it's got to actually apply this. But I think that you're going to see that we're going to get a bunch of new transitions, and those new transitions represent, yeah, so now we have 263,000 transitions. And if I expand here, you can see that I now have these precursor transitions, which don't have these library scratch marks. These are MS1 transitions, and they're the isotopic distribution that we talked about, that we've been talking about for DVA, is monoisotopic, M+1, M+2. And so we could extract those two, and those would give us new information. They would add some scores to our M-profit model, and they do add a little bit of value, but actually DIA does do pretty well without these precursor transitions. And again, I opted for fewer transitions to make it a little bit more teachable. But that's a long answer to that one. Let's see. When I install MS Stats, I got this message: installation path not writable, unable to unpack packages. Yeah, so yeah, I mean, that probably means that you don't have administrative privileges on that computer. Usually there's some way, and I'm not sure, it's unfortunate that I don't have an R expert with me. Usually there's some way that you can install, I think I have some, but usually you can install, so here's R. You can get R to install libraries into your documents folder. And I don't know exactly what you have to do on RStudio to make that happen. But I don't have a better answer for you, but I would Google this, hey, we couldn't, not writable to my program files. And I'm sure it will give you some instructions for how to write your libraries to your documents folder. what is the best way for decoy settings DIA analysis? Well, I like shuffled because there's no risk of that actually being something meaningful. There are some search engines that will add they use reversed peptides for decoys, and so if you then use reverse of reverse, now you're using forward. But just in terms of the analysis we're doing here, actually reversed and shuffled would work, I think statistically indistinguishable from each other. So yeah. So what we did is fine. You could have had it be reversed for that purpose. I can't seem to point to Skyline to my R location. Is there a specific directory that I'm supposed to choose? Skyline, so Skyline Batch should auto detect your versions, and maybe, if you installed while Skyline Batch was up, maybe you have to, you might have to, let's see. So if I go to reports and then if I add an R script, so I assume you're saying that, hey, my R version doesn't show up here. The R version I'm expecting doesn't show up here. You can add an R location, and then you point to the R location. And if it really truly is, so that's one way. Like, it may be that your R location is actually under documents. Yeah, so this is showing under documents. If you're like, oh yeah, it is under documents, and this is my R location, I want this 3.5. If it really is an R location, yeah, it says no R installations were found. So if it really is, Skyline Batch will go, oh, there it is, great. So that's how you would add an R location if Skyline Batch is somehow not finding yours, though it generally does a pretty good job. And I saw it have some trouble picking up 4.2 right after I installed it, but after shutting down Skyline Batch and coming back, it eventually picked up that R.2 was on my computer. So that's about all I can tell you about that one. When I tried using a raw file for editing the isolation scheme, I got the following: instrument index not available for requested device. So presumably this is not our raw file. This is your special raw file from your computer and from your instrument. So I would just say, that's great to post to the Skyline support board. If you're not familiar with the Skyline support board, it is actually the people, most of the questions on it get answered by the Skyline developers. So if you go to Skyline, actually right up here, you can click support. And then this is the Skyline support board, and we highly encourage you to, I'll try to announce this to the class as well. We highly encourage you to post requests there. We answer them really quickly. And if you view this list, then you can see that at this point, there's been over 4,000 requests that have been answered. Nick does a lot of the support, but the rest of us chime in as well. So I would say, if you're really getting that, yeah, what is it? Was a Bruder file? It was a Bruder file. Boy, I have no idea what instrument index not available for requested device. Yeah, I don't know. That sounds like yeah, I don't know. I don't know what's gone wrong there. Maybe try it on another computer, try a new, uninstalling Skyline and reinstalling. Yeah, not quite sure what's going on there. But again, you could use the support board if you, yeah, and somebody could help you run down what's going on. To follow up, at our location, can't find R in folder R 4.1. I use regularly and successfully installed MStats. Am I out of luck? Yeah, are you sure? There's an R, there's like a, what is it looking for in these folders? Yeah, again, you could post this to the Skyline support board. These types of questions require troubleshooting, which I may or may not be able to do quickly here. So I think, when you're looking at so the kind of, I think this in my documents folder, these R things are actually just our libraries. So they don't actually contain R, they just contain the libraries getting downloaded for those things. So this is an R installation, and I'm pretty sure that it's looking for like R script exe. So go to the folder that you're pointing Skyline to, and if you actually see a bin and an R script exe, yeah, then go ahead and post that to the support board, and we'll really look into it. I have no idea why that would be a problem. Issue to install our package despite having 4.3 on RStudio, just got error message. Any trick? So this one I answered. So there's somebody saying, hey, I have R 4.0.3 on RStudio, and I just got an error message trying to install. Yeah, I think Lawrence Bindscheller. Can I actually find you? I could make you, let's see, are you still there? Yeah, okay, so I'm gonna make you, I'm gonna promote you to a panelist, Lawrence. And so I think that should allow you to share your screen. If you're still there. So if you're still there, share your screen, and then you could, then we could look at the error together. I'm using Skyline daily, so that shouldn't be a problem. But when you are working on your configurations, you would have this as an option, whether or not you want to run with Skyline or Skyline Daily. Maybe it would auto choose Skyline Daily, because if you have, I don't know whether you have both Skyline and Skyline Daily. If you have both, just go ahead and use Skyline. But if you want, if you already created your template with Skyline Daily, yeah, you get the option here. You can choose Skyline Daily, or if you've downloaded some installation, you could use that too. But or if you have the administrative installers, you might be wanting to use this. But yeah, you can run these configurations on whatever version of Skyline you want. What does data mean in DIA or DDA? Thanks. I don't know. I don't know what that question is really about. Okay, so the question is, how can I make IRT CSV file and what is in it? Generally you wouldn't need to, and you would just go ahead and choose one of the options. When, like, I sidestepped choosing one of the options and went directly to importing that. I think that was to avoid a bug that hopefully is fixed, but I didn't have time to test it. But yeah, so typically you would not need this. Here in library, we have this Biognosis IRT CSV. And, you know, it I think is actually pulled from the Biognosis IRT standard specification. And it's just a small 34 line thing that specifies all 11, and it actually only specifies 3 transitions for most of the peptides. So it's just saying, hey, this is what I want to measure for my IRTs. And if you choose the default, then you'll get what Skyline has. And if you just choose, I said, before I chose the CSV, I say you could choose this 11. And then I didn't, and that was because there was a bug in that last year. I think it's probably fixed, but I didn't retest it. So really, the answer to that is you should not need this. But if you do, there's a copy of it, you know, and this is just as usable, you know, exactly this CSV is just as usable by you anytime that you feel you want to include the IRTs when you have an assay library. This is a usable artifact that has no relation to anybody's system or anything like that. So you have a copy of it now, you know where to find it. It's up on Panorama. We downloaded it here today. So how do we prepare IRT file? I mean, this IRT file, I'm not quite sure what that's saying, but anyway, so yeah, IRTs are a whole other subject, and we could, you know, I've spent an entire hour trying, you know, explaining it. There's a whole tutorial on IRT, and I would say, you know, I would also still highly recommend doing more of the tutorials. There's actually, yeah, there's both a webinar on IRT. So this is the IRT webinar, and this is the IRT tutorial. And then inside the tutorials, I just highly recommend this DI data analysis tutorial, which has, you know, was recommended, and then there's several webinars that go with this tutorial. So all right, I'm out of questions. What's in the chat window? I'm going to head off. Okay. Yeah. Okay, so I'm still here, but I think our numbers are dwindling down to 30. Probably some of those people just left their computers running. If you feel like is there anybody who's like working on anything? Anybody want me to stay longer? If you want me to stay longer, just put something in the chat. Otherwise, we can wrap the session up. All right. Okay. Thank you very much. All right, cool. Well, so we'll be back tomorrow. Give it a shot and try to get your data processed overnight using your configurations or the BCFG file downloaded, but try to get a fully processed. So you want to try to get to, I have both the Bruder data we've been working in today, as well as a fully processed file where if I go into this folder, I even have PDF files generated by MSStat. So that's where everybody would ideally get to tomorrow. Good luck. Bye. Have a great day.